Good morning, everyone. I'm pretty happy to be here, and I'm also happy that there's such a large interest, it seems, in type annotations. Probably some of you already heard of type annotations in Python, or maybe even used them. So that's a good thing, because type annotations are actually a pretty old feature already. And I wanted to give this talk because right now there's a lot of activity in this field, and as I personally have worked a lot with static analysis and I'm interested in everything that is connected to code quality, I found this an interesting and very good opportunity to actually have a look at type annotations again and see what happened in these ecosystems in the last 3 and 4 years. And spoiler alerts, it's quite a lot that happened. So I have 3 learning goals for you in this talk. First, I want to explain to you why actually we need type annotations, or we might need them, and how they made their way into the Python language. Secondly, I want to show you how you can actually use those type annotations and type hints in your own code base. And for that, we're going to have like an integration project where we take a small code base and actually try to put type hints in there. So then I want to show you also not only how we can use type hints, but how other people are using them in the wild, so in public projects, and to see if actually somebody else is even is doing something with that. So finally, then I want to show you what else you can do with type annotations if you're not interested in type hints. Okay, so the first question you ask yourself is probably, why do we need type annotations at all? I mean, after all, our code is just running fine without them, right? So to answer that, we will just have a look at how and when we find bugs when developing software. So if we ask ourselves, what's the first opportunity to find a bug when we have a new software project? And it's actually not it starts even before we write the code in the design phase, because we could just, in a perfect world, think about what we want to build, like think about all the edge cases and all the input variables that we might have in our problem, and then with that perfect specification, just write the code and have something that has no bugs in it. And of course, this would be nice, but this almost never happens. Actually, there are some systems that can help you to write software that is almost bug-free, but most of these do not apply to many of the daily projects that we are working on. So unfortunately, we have to do something else. The next opportunity to find a bug in our code is after we have written the code. And for example, you could have somebody else look at your code and try to find bugs in there, so-called code review. And actually, this is a pretty good way of identifying bugs if you believe the empirical studies that exist. So if you're not doing this already, you should really start doing it. And as an alternative, instead of having a human read your code, you could also feed it to a computer program, so-called static analyzer, and have that static analyzer try to find bugs in your program. And for Python, there are also several solutions available for this that you should use, and they can help you to identify some of the problems that can occur in your code. And okay, the last point actually doesn't apply to Python, but it applies to other languages. For example, if you have C++ or Rust, you have a compiler that takes your code and puts it into an actual executable form. And while doing so, it also performs a lot of so-called type checking. And using this type checking, it can tell you before you run the program if there's actually some problem in there, because there are some types that somehow don't fit together. And as you know from your Python experience, the Python interpreter in that sense is very lenient, because it allows you to almost run any code at all, any code you want, as long as it corresponds to the Python grammar. And I mean, you probably all know the situation where you just make a small change in your code, and then it just you run the program and it works fine in the beginning, but at some point it crashes because you might have forgotten to include like an import statement, or some of your variables that you're using deep inside your program are undefined. And so this is a situation where like a compiler would really come in very handy, because it would catch those bugs already before. Okay, so if you can't rely on that, what can we do to find other bugs in our program? Well, we can build a little exercise yard for our code and test it. And that's what we're doing a lot via unit testing, functional testing, and integration testing, with the goal of actually running as much of our code as possible and running it through as many different situations as possible in order to identify possible edge cases or things where the code might break. And this is also a best practice, so if you're not doing this already, I heartily recommend you to start with that, because it can help you to find many bugs in the program. And so the last method that often is not discussed, but which is quite useful to find bugs, is, of course, not find them, but have the customer do that. And that's what I call the so-called banana strategy, because if you know, if you like shipping bananas, you actually take them off the tree when they're still green and unripe, and then you let them ripen at the customer's side, so to say. So with software, you can do the same. You just ship unready code, and then your customer kind of discovers the bugs for you, and then you go ahead and fix them. And again, I'm not saying this is a bad practice or something, it happens a lot, but it's not always what we really want, because ideally we want to deliver software to the customer that is working as expected and not have him or her discover the bugs for us. And the Python community also thought that, and that's why they decided to do something which is a bit like implementing a compiler for Python by having a system that makes it possible to actually check our programs for internal consistency before we run them. So a type checker for Python, if you want. And that's what type hinting is about. Now, the problem is, of course, there are already like billions of lines of Python code out in the wild. And you know from the situation we had when we tried to convince people to switch from Python 2 to Python 3, that it's not so easy to get people to rewrite their whole code in a new system. So if you would just introduce like a new version of Python that would require everyone to like statically type all of their code, this would be a very good way to drive people away from Python or have a fork in the Python interpreter maybe. So that's not the strategy that the Python community pursued, and instead they did this so-called gradual typing, which is also pursued by other languages like TypeScript, for example, and which lets you, instead of having to statically annotate your whole code base, just lets you add type annotations or type hints to like small parts of your code where you think it might be worth having them. So if you see here, we have some external code, for example. In gray it would be unannotated code, in green it would be annotated code, and then you can write your own code basically, and you can also decide for which parts of your code base it actually makes sense to have these type annotations, because maybe the code is really critical, or maybe you really want to be sure that there are no mistakes or no errors in that code. And so this is nice, but of course now you need a system or a way to also interface your own code with the external code that might or might not have type annotations. And later we will see how exactly we can do that in Python. All right, so type annotations by themselves are actually not a new feature, and so I want to give you a short history of that. The first change that led to this current state was the introduction of so-called function annotations, which was done in 2006, so more than 10 years ago, and it was formalized in this so-called PEP, which is a Python enhancement proposal, and that's a formal way, so to say, to get new things into the Python interpreter or the language in general. And this PEP 3107 introduced a new syntax that would allow you to write these type annotations in your Python code without, though, giving any meaning to those annotations. So basically what you could put in there whatever you wanted, and the Python interpreter would just ignore that. And this feature landed in the Python 3.0 version in 2008. And after that, not much happened for a while. You know, the community just wanted the users to decide what they wanted to do with that feature. I think honestly users didn't do much with it, if at all, anything. So in 2014, that's why the community again decided to introduce some new feature, so-called type hints. This is PEP 484, and this is actually the PEP that gave meaning to the annotations that were introduced in 2006. And there are also some other PEPs here, 482 and 483, which explain the theory and the ideas behind the type hints. So if you're interested in that, you can check that out by just replacing the number and inserting that into the URL that you find below. So this new feature set landed in Python version 3.5 and allowed us for the first time to really have a formalized system of using type hints in the language. Now you could think that might be the end of the story, but actually no. there are still some open and active developments going on here. For example, in 2016, there was another addition to the syntax of Python via PEP 526, which introduced a small change, but a new possibility to also annotate a different type of thing, namely a variable, because that's something that the writers of the original PEP in 2006 didn't think about, but which turned out to be quite useful if you want to do good type checking. So that's something that they implemented just like last year, and which landed in the new version of Python 3.6. And there's still some ongoing changes here, for example, PEP 544, which I find really exciting, which is about so-called structural subtyping via protocols, but which we're unfortunately not going to talk about in this talk because it goes a bit too far. So, as you can see, it's still a very active area where new things are created, and it's at a state right now where you can actually start using it. So now we probably say, okay, stop with the theory, let's show me the syntax already. So here's an example in all its glory, and you might already spot some of the unusual things here, or some of the annotations in the code base. So you can see here, for example, we have a so-called argument annotation, which annotates the input value to a function. And if you annotate the input value, of course, you also want to annotate what comes out of the function, so the return value. And this is done via a so-called return type annotation, which you see here on the right. And this is done by this arrow syntax. And the final element is this new so-called variable annotation, which was introduced in Python 3.6, which also allows us to annotate a variable inside a function body. And you might ask yourself, why do we need that? Well, it's actually useful because here, what we have is that we initialize a result variable with an empty list, and for a type checker this would be a problem because it would only know, okay, this is a list, but it wouldn't know what you would actually want to put into that list. And so this we can tell to it by saying, okay, we want to have a list of integer values, and that's the main motivation why this feature was added. Alright, so if you take a step back now and actually think about what those type hints or type annotations are doing, well, if you just would run that code with Python 3.6, it actually would do not much, nothing almost, you know. The Python interpreter would just take the annotations, put them in a magic variable, which is called __ annotations, and then just go happily running your program without any runtime effects at all. So by putting these annotations, you do not change the behavior of your Python program per se. Now, you also saw maybe that we're importing this weird module there, which is called typing. And the motivation behind this typing module is that if we have a type checker, if we want to implement one in Python, we of course need a way to specify what types we actually have. And we have some built-in types like integers and floats where you could do that directly in the code base, but often we have types which are a bit more complicated. So for example, dictionaries that map strings to integers or lists of given other types, you know. And the typing module helps us to specify these types by providing us several classes and several ways to generalize these classes and adapt them to our own need when we are type annotating our program. You can see here two examples. We have a mapping of a string to an int in the third parameter, and we have this list of ints inside the function body. So, okay, now you're probably asking yourself, okay, if the Python interpreter doesn't do anything with that annotations, then how are they actually getting used? And the answer is they're getting used by external tools. So there are several of them available. For example, the most popular one right now is probably MyPy, but there are also some IDEs like PyCharm that can use these type hints, and these external tools actually do the heavy lifting in type checking. So they go through the Python code, look for the type annotations, and then try to make sense of them and try to find problems in the code. And this decision of having that as an external tool and not as part of the core language was a deliberate one, and I think it's a good compromise in order to have a system that is easy to evolve. But I think eventually a lot of that functionality might also land in the core Python interpreter, or at least as a tool that is shipped with Python. But right now, you have to install an external tool for it. And now we're going to look at one of these tools, that's so-called MyPy. And MyPy was written by Yuka Leitosalo. I probably horribly mispronounce his name right now, who's, as far as I know, working at Dropbox now and developed many of the ideas for MyPy during his PhD thesis. And the good news is that MyPy is strongly pushed by a team at Dropbox under the lead of Guido van Rossum, which should give you some confidence in the stability or like at least the active development of the tool. And it's pretty easy to install. You can download it via pip and then just run it on the files, which we're going to do in a minute. And here on the right side, I also included their website, which you can see is quite active, and they have like several releases, almost one release per month. And as you see from the version number, the tool is still evolving, but it's already functional enough so that you can actually use it. Okay, so if we want to use it, we need, of course, an example code base. And I choose a project I did for the, an open source project I did for the German cybersecurity organization. It's called Floor. Floor is a German translation of the word bloom, and you might have heard of bloom filters. So what the library is doing, it provides such a bloom filter. And what does a bloom filter do? Well, it's a so-called probabilistic data structure to which you can put in some values, and then you can later ask the bloom filter, have you seen this value or not? And if you have put in the value, the bloom filter will always remember it and always say, yes, I have seen that value. But what can happen is also that it misremembers something. So it might answer, yes, I've seen that, with a value that you actually didn't put in there. And this might not seem terribly useful, but it's actually quite neat, because we, at the DCSO, we have lots of indicators, for example, domain names, corresponding to domains that like control malware or download malware onto computers. And we want to check those domains on a local machine, for example. So what we can do is we put all those values, like 100 million, into a bloom filter, which is then about, depending on the probability that we choose of this misremembering, about like 100 megabyte large, and we can just copy that to the machine and ask the filter every time, have you seen this domain or not? So pretty useful library, very small code base, and we're going to try now to add annotations to that and see how that goes. So I choose a code base, as I said, because it's really compact. It's less than 200 lines of code, but it actually does something useful, so, which I always find better than using like a toy example just to show how the stuff works. So it's actually something that people use in production. And the nice thing about it is also that it doesn't have any external dependencies beyond the standard library, so you don't have to type, annotate, or interface with any external code. And again, this is good because it makes it easier. I don't want to give you the impression, though, that it's always that easy to annotate code. So of course, if you have large projects, you will need to put in some more effort to do type annotations. But in order to get started, I think it's a good project to just see how it works in theory, but you can also actually do that with a larger code base, of course. And it doesn't also have many exotic types, so most of the types that we're using in there are built-ins or simple compositions of built-ins like lists or dictionaries, so it's not too hard to understand what's going on, I hope. And last thing is that we keep that code base compatible with Python 2 and Python 3, because some of our customers, they can't use Python 3 yet. So it's also an interesting case to see how type annotations can actually work for a Python 2 code base. And in order to test that, we need a script, of course. So we have like an example script here which imports our library. It creates an instance of this bloom filter class, which we initialize with two values. So normally it expects a value n, which gives the number of the elements that are in the filter, and a probability p, which gives the false probability rate. So the probability that the filter will misremember a value that we didn't actually put in there. And the number of elements should be an integer, of course. The probability should be a float. And you can see here we instead put in a float and an int in the wrong place. So this is something that would blow up, so to say, in runtime. And then secondly, we want to check or add a value to the filter. Again, we have a problem here because our filter expects an array of bytes. And what we put in here is a Unicode string. So this again would be an error. And lastly, we want to do something with the fingerprint of a given value that the filter returns. And what this function actually returns is a list of integers. But here, our user kind of assumed that it would be a string, and he tries to, or she tries to add another string to that, which of course, again, is a problem. And now let's see if we can get MyPy to find these problems. So in order to add type hints to our code base, we would go through the code function by function and then try to add annotations to the arguments and to the return types. So if possible or if needed, we also might add annotations to other variables inside the function bodies or inside the module to help MyPy actually make sense of them if they're not used as a part of a function argument or return value. And to do that, we need to import, of course, the necessary types from the typing module. And then, if we have done that, we can just run MyPy and try to make it happy, so to say. All right, and the result of that is shown here. So you can see that we added some type annotations to our init function. So we specified that n should be an integer, that p should be a float value, and we have a function also to read a Bloom filter from a file, which of course expects something that you can read from. And there's also a way to express that using the typing model, which is this IO class here. And so what we're doing is we're telling the read function that we're expecting an object which is readable and which returns byte that the function can then use to read into the Bloom filter values. Finally, this contains function which checks if a value is in the filter, expects of course a byte sequence, so a byte array, and returns a Boolean value, which we also annotate. Okay, after doing that, we can just run MyPy. This is shown here. So you can see on the left, I specify this environment variable, which is called MyPy path, which we need here because MyPy actually has its own search path. So if we want to check some external code, we need to tell MyPy where it can find that code. And in my case, I have my Python libraries here in the libs folder, and then I run MyPy. I also tell it which Python version to use. In that case, we want to use Python 3.4 because we don't use any variable annotation, so we don't need 3.6, and it's not running anywhere on my Ubuntu machine. And then we tell it the file that we want to check, in this case floortest.py. And hopefully we would get then out all the information about the mistakes that are in that file. But to my surprise, what I got out of there instead was this like really weird cryptic error message, which really made me doubt if I actually understand anything about type hints at all. So I was really like, when I do this, I said, okay, Andreas, this is easy. I got this. I'm just going to annotate that stuff. And then I said, what? Why bytes? But this should work, you know? And so I was like digging in the documentation and I tried to do some debugging. And finally, I found the reason why this is not working. And the reason is actually that I broke MyPy with that. And the problem here was that I had in the Bloom filter class a variable which is called bytes, and which MyPy somehow mistakes for the built-in bytes type. So when I try to initialize that class here, MyPy thinks, okay, bytes, this is a variable, but this is not a valid type, so I'm going to throw an error, and then just crashes. So as you can see, it's still not perfect, but on the other hand, as I say, always like the debugging of your system is only as good as your most stupid user, and probably I kind of lowered that bar for MyPy by naming my variable as just like a built-in type. But the good news is the guys who are developing MyPy, they're really awesome. So I posted this issue here on Monday. I got a response to that in like 30 minutes, and yesterday morning it was already fixed and merged into the master. So as you can see, they're really like are very active, and they really take feedback and bug reports very serious. So if you have a bug that you encounter when running MyPy, I encourage you to just go to the GitHub issue tracker and post it there, and they will definitely help you resolve that in as fast as possible. So having that fixed, a quick workaround, by the way, was to just rename my variable with an underscore, and then it didn't complain anymore. So the results of that, we can run it on our script again, and amazingly, as expected, it finds all the 3 problems that we put in here. So you can see when we initialize the Bloom filter, it says, oh, this is an incompatible type. I'm expecting a float here, an int here, but I get a float. There's actually also an error for the second message, which I don't show. Then we try to add a value to the filter with the wrong type, and there MyPy also complains and said, oh, here you should put in a byte object, but I actually got a string. And finally, it says, oh, here you try to add a string to a list of integers, and this is also not possible. So this is pretty cool, I find. I mean, it might not seem like a big thing, but you have to realize that just by adding like a few snippets of additional code to our project, we made it really much harder for our users to use our code the wrong way. So we make it much easier to like have a good state in the system and to avoid problems when using that library as a user, but also, of course, make the code better for ourselves, you know. So normally this could be the end of the talk and we could go home, but if we just push that to master, it wouldn't take long for customer complaints to roll in because, as I said, some of our customers still rely on Python 2, and since type annotations are not supported by Python 2, adding them to the code base would just break it. So that's bad news, huh? But can we do something about that? Yeah, actually we can. And because MyPy, our type hints, have a second approach for adding these type annotations to a code base, which are called type comments. So type comment is similar to a type annotation in the sense that we specify function arguments and return types as well as variables, but instead of doing that in the code, we do it as a comment. So if you would again do the same annotation as before of our code, only this time using comments, the result would look like this. So you can maybe, I hope you can see them. So we have one comment after the init function, which starts with this magic word type in a colon, which tells MyPy that this is a type comment. And then afterwards, it contains the signature of the function. So it says, okay, we have an integer value, a float value, and we return nothing. And you can do that for all of your functions again as before. And the nice thing about it is you don't have to use the new type annotation syntax. What you still have to do, though, is, as you can see above, import the relevant types from the typing module, which is possible, though, because the typing module has been backported to Python 2.7, so we can just install that via pip, for example. Okay, now we're fine, right? So actually, no, because there's also often code that we just can't change, maybe because of the code is upstream somewhere, we don't have like the write rights, or it's an external library that we want to use. So there we're really out of luck, both with code, with type comments and with inline annotations. But luckily, again, there's a third approach that we can use for scenarios like this, which is called a stub file. And I've shown you here an example of such stub files. So here we have our directory with the code file. So we have our init.py, the filter.py, which contains the code that we saw earlier, and some helper functions. And what you can see here, that we also put some new files in there, which are ending with pyi. And these pyi are, of course, the stub files that we're talking about. And MyPy, when going through a code base, will also try to find such stub files. And it has its own search path for that. So it will look, for example, in the current directory, in the search path that you give it via this MyPy variable, environment variable, and also in another place which is called a type shed, which is a GitHub repository that contains many type informations for example, built-in Python functions and also third-party libraries. So, and the thing is, if MyPy finds a pyi file, it will only load the information from there and will completely ignore the corresponding py file. And this means we can, instead of like changing our code, just add this pyi file, and add the type annotations there. So again, it's the same operation as before. We just start with our code and then we go through it. But now we, in addition to adding the annotations, we also remove any actual code that is doing stuff, So you could, I probably think about this as like writing a header file for Python. I don't really know if I like that concept or the idea, but it's very similar to have a C or C++ header file where you specify the type information, then have an actual Python file that implements that interface, so to say. And the result is looking like this. So you have here again our class with the different functions, and you can see that we added our type annotations, but you can also see that instead of having the function bodies written out, we just put this ellipsis there, so these 3 little dots, which tells MyPy that this, okay, there's a function body coming afterwards, but it's not important, so we don't put it there. And so this is a very compact, very nice way to specify the typing information for code that we can't actually touch. And we can, as I said, store that in various places and have then MyPy look for that information when we try to change, to check code that actually uses our library, for example. So these are 3 approaches that I showed you, and now you might wonder, okay, which one is actually the best or how they compare in practice. And to get an idea of that, we push these 3 new branches to GitHub, and we have a Travis CI integration there, which automatically tests our code against different Python versions. And as you can see, the results are here. So for the, if you look at the last elements where we have our stub files in there, our code is still compiling or running fine, which is not surprising because after all we didn't change any of the Python code, we just added some new files that the Python interpreter doesn't care about. So for the interpreter those files don't even exist. But for the other two cases where we use inline type-ins or where we use commented type-ins, we actually get an error. And if we go look at the details of that, you can see here the results for the inline and for the commented build for different Python versions. So we can see that if you look at the left column, the inline build for Python 7 of course fails because there are no type annotations in Python 7 and this 2.7. And the same of course for PyPy and PyPy 5.3.1. Here this failure for Python 3.2 and for Py 3 is more surprising because you see an exclamation mark there instead of an X, which means that something went wrong during the setup of the test and not during the actual running. And what went wrong there is that we tried to import the typing module, but unfortunately the typing module requires Python 3.3, so Python 3.2 can't import that and neither can PyPy, and that's why those two tests are failing. And the same is basically the reason why the commented type-ins are failing here, because also we only have comments in our code, but if you remember, we still need to import the typing module, so we still have the dependency on that. So this is why the code is not running on Python 3.2 or PyPy. Actually, this is not really true because I found a workaround for this, which is maybe a bit ugly, but it works. So you can, if you follow this link here, actually also make the commented type-ins work in Python 3.2 or PyPy 3. All right, so which approach should you use? If you look at the inline approach, that's kind of course, the right way to use type-in. It's the way type-ins or type annotations are intended to be used. And the advantage is that it's easy to read and that the code and the hints are kept in one place. The drawback is, of course, that your code will only be compatible with Python 3.3 or if you use variable annotations, Python 3.6 even. The alternative here, using type comments, is good because it keeps the code compatible with Python 2.7, and it also allows to use variable annotations, but it might be a bit ugly and it also still requires importing the typing module, which there's a workaround for though. So the final approach using the stub files is nice because it doesn't modify any of the original source at all, and it allows you to use always the latest features that are available in MyPy. So the disadvantage is, of course, that you can that you have to write now instead of one file, two. So you will kind of duplicate your maintenance efforts, and you will always have to take care to keep those two files in sync with each other, which is not always easy. So. All right, of course, there's much more to the to type-ins than this, and we just had a look at a very simple example. If you want to learn more about that, I recommend you to check out the documentation of the typing module, which contains information about how you, for example, can create types for your classes or class hierarchies, how you can use so-called generics. So think about a list that contains a different element of a given type, or like a new structure that you invent and that you use in your code. So the typing module provides support for all of these use cases and many more, like generators, asynchronous things. So it's really very well documented and can help you to type most of the variables that you will find in your everyday Python code, I would say. So probably now you say, okay, well, this is nice, but is anybody actually using this already? I didn't know that, so I checked. And what I did for that is to download the top 1,000 repositories, Python repositories from GitHub, which you can easily do through the API, and then download the code of that and check it for inline annotation, type comments, and stubs. So the code and the analysis can be found on GitHub. I just want to show you the results here. So what you see here on the left is an image showing you these 1,000 projects that are analyzed. So those are really the most popular Python projects on GitHub. And the color code represents the number of type-ins or type annotations that are found in each project. And you can see here on the bottom there's a scale. So it goes from 0 type-ins, obviously, to about like 10,000. And if you look at the number of projects that actually use type-ins, you can see that from these 1,000 projects, there are 103 projects which have at least one type annotation in their code. And So you might say, okay, this is like a homeopathic dose of type hints, so maybe it would be more useful to see the project that actually use many of them. And if you go, for example, if you check the number of projects that have at least 10 type hints in the code base, then it's going down to 53 already. And if you check for projects that have 100 in them, it goes down again to about 24. So you can see that popular projects on GitHub, they're already starting to use type annotations. Some of them are really embracing them, but others are just like maybe experimenting with them or like using them in some test cases. And in order to see which kind of type hints they're using, you can also have a look at the right diagrams here, which shows you the usage of inline type hints, type comments, and PY files. And if you're looking for some great examples of type annotations or type hints in Python code bases, you can have a look at these repositories. So the first one is no surprise, of course, because it's the MyPy project. So I would expect them to use type hints if they're like writing that, okay. The second one, I don't know, you might know that if you have like a connection to Hacker School or Recourse Center, because I think they use that as their main discussion system. It's called Zulip, and it's an online community system which was also acquired by Dropbox, which might explain why they're using type hints a lot. So that's the second project. I mean, these two you could maybe discount because you could say, okay, they're working, they're part of Dropbox, and maybe they are forced to use type hints, maybe they don't like that even at all. But the third project is something that you probably use a lot, which is the Sphinx documentation generator. And I was actually surprised that they are using type hints, but they have a lot of them in their code base, about 4,000, and I find they really made very well use of them. So if you're looking for a code base with good examples about how to use type hints in a really large project, you should have a look at that. And afterwards, there's still, you can see the number of type hints in the projects is going down rapidly. There are some other things here, which is, I think this URH project is a radio hacking tool. You have some home automation tools here, a proxy, and some AWS related stuff. So overall, you can see that like of these 1,000 Python repositories that we looked at, there are at least 10 that I would say use type hints or type annotations in a serious way. All right, so I'm almost through. The last thing I wanted to show you is that you can actually use type annotations for other things than type hinting. Because if you remember, I said the type annotation syntax was introduced in 2006, and it wasn't tied to any actual use case. So it was deliberately left open so that users could just use that additional syntax to do stuff with it. And now if you look again at a simple example of a function with type annotations, or like annotations in this case, you can ask yourself what is happening actually when we run that. And as I said before, what the Python interpreter does is that it like creates a special variable called __ annotations, where it puts everything that you put after the colon here or after the arrow, so to say. So that makes it really easy to access that information at runtime, and it allows you to then build stuff on top of that. And as an example, again, I don't show you much code here. If you want to see how it's implemented, you can look at the GitHub gist here, which is linked below. So what I did as a small demo is to build a runtime type checker using these annotations. And it works like this. So you have a function here, which in this case takes 3 arguments, and we want to make sure that the first argument is an integer, which is in the range between 0 and 100. The second one is a float, which is between 20 and 40, and the third one is again an int between 70 and 80, which also has a default value. And we also say that, okay, the return value of that function should be a positive float value. And this is a so-called contract, because you're specifying not in the body of your function what the values should look like, but already in the definitions of the arguments, and then you have like a system that enforces that for you. So if you call that function with an argument that does not correspond to the contract that you have, the decorator here, which is called check, would complain about it. And this is actually quite easy to build with this type annotation syntax in Python, and it took less than 100 hours to implement it. I didn't know if I should put it here, because I'm not sure if it's a good idea, because the thing is, if you use it in this way, you will of course break the type hinting with it, you know, because tools like MyPy, they expect the type annotations to make sense. So if you put something like this here, which MyPy doesn't understand, it will be a problem. So that's why I'm saying if you can use the stuff in that way, but you should think about it well. Okay, to summarize, I hope I could show you that type hinting in Python actually works and makes your code more robust for yourself and for your other people, that you can already use it now even if you have Python 2 code bases, and that annotations can do more than type hinting if you want them to. Alright, so that's basically it. You can get the slides on SlideShare, you can find me on Twitter or contact me via email, and now I'm happy to take your question. Thank you.
Thank you, Andreas. So, questions?
Thank you for the talk. Are there any plans in predictable future you are aware of using type annotations for optimizing bytecode generated by compiler?
Yeah, I think there are definitely ideas that are going in this direction. I think the PyPy project, they considered this, but they said they had like other sources of information that they can use to do that optimizations. But of course, like having these type annotations in the code makes it much easier to do like specializations of your functions. So you could use that definitely to make Python code run in an optimized way, or even have like a virtual machine that is running, that is compiling it to something else. I mean, Cython is basically doing this by using a kind of different annotation syntax. So yeah, it's definitely possible.
More questions?
So do you suggest to also write unit tests, the test for the correct typing? If you remember, you showed that the test script that first failed and then correctly failed.
Yeah.
So do you suggest also that we should do this with unit tests?
So the idea of the type checker is, of course, that you don't need to write any additional code to check your code base, so to say. You can, of course, do that, but this was mostly an example where I wanted to show how you can use the type checking, how users of your library could use the type checking in order to make sure that their code is using your code correctly. And you can, of course, like write your own tests, but it's not really necessary in order to benefit from the type checking information. Yeah, but it's possible. Yeah.
Hi. You show how to access the information of annotation in the function. Is it possible to access the information of annotated variables?
Yeah, it's possible. I don't remember where exactly it's stored. I think it's also inside like an annotations object, but I really have to look that up. Yeah, but yeah, and you can also, of course, get those the annotations in the AST, which is how I found them in the Python projects on GitHub. So I just didn't run the code. I just compiled it to an AST using the AST module, and then looked for the annotations in the syntax tree. Yeah. So both ways are possible. Yeah.
Hi. So I've noticed, so with the type checking, is there support for multiple types? So say X is int or float?
Mm-hmm. Yeah, there's. I didn't show that, but the typing module actually has support for many of the things that you would need in a typing system, including so-called union types. So a union type would basically allow you to say, okay, this variable, it could be either a list of integers or a list of floats or maybe something else. So you can do that. I didn't show that, but it's possible, yeah.
Hi there. Nice talk. There is also maybe a reason why Sphinx is using so many type annotations. You can have a direct benefit also by using an extension for Sphinx that will put your comments, like if you use type comments, then it will search for them and put them in the documentation.
Okay, yeah, of course, that's a good reason. Yeah. Thanks for pointing that out.
Does MyPy also do some sort of type inference?
So I don't know how MyPy works internally. I've written some static analysis tools myself. So normally what you do is you try to construct like the call flow graph, control flow graph, or like convert the code to like single SSA form and then do something with that. So I'm not actually sure how they do that, but yeah, there's definitely some type inference involved. So what I didn't show you in the code examples was that I can just go back here. You see that we have like these definitions here of the of P, N, and the big N, and there we just put like a literal in there, and MyPy can of course then figure out that the value in there has a type of integer, for example. So it can do some of that stuff. It doesn't do, I think, too much of it, but for simple use cases, it can actually infer the types. Yeah.
Okay, maybe finally a question for the audience. Who of you is already using type hints?
Oh, awesome.
Who is using them in production?
Ooh.
Nice. So this
great.
question will be asked again next year, and we hope this number of hands goes up. So thanks again, Andreas, for this very nice talk. And everybody, please remember to rate the talk in the app and give some feedback to the speaker and the organizers. Thank you.
Okay, thank you very much. Thank you for coming, and good morning. I know I'm standing between you and lunch, so I'll be brief. My name is Paul Ross. I work for AHL, which is a systematic hedge fund in London. Here's a little bit about us. We've been around 30 years this year, which is quite long for hedge fund terms. We trade in about, we're systematic, so it's the algorithms that do the trades, not discretionary traders. We're active in about 400 markets all around the world. We gather about 3 billion market data points every day. We've open sourced our tick store. You can find it there on the Man AHL GitHub account, Arctic. It's been very successful for us. We're quite a small organization, really, for what we do, and we all speak Python. So this talk is really based on our experience of using Python as a systematic hedge fund and the things that we've had to do when performance isn't what we would like. So there's kind of 3 sections to this talk. One is just to introduce the concepts and to scope out the talk, because performance is such a big subject, it can't be all covered in 45 minutes. Then there's a lot of technical solutions out there you can have to make Python faster or your code run faster. And it's somewhat confusing looking at all the different solutions, so I try to create a kind of technology taxonomy, really, to make sense of all these different options that you have, and so you can reason about them intelligently. And then finally, I want to talk about evaluation criteria, how you evaluate the different solutions that are on display here. So first up, let's have a little introduction. So firstly, what this talk is, it's really kind of like a tour through some of the Python or alternatives to Python. This is for general purpose computing, okay, not specialized computing. So all the solutions I offer you are sort of general purpose solutions for compute power. It's also going to be a way of evaluating alternatives, so you can decide which one is good for you. And it's also a reflection on the trade-offs you're inevitably going to make between things like performance and maintainability and cost and so on like that. So I better say what this is not about. Okay, I will mention NumPy a bit. This is not about NumPy and pandas. So if your problem domain is one that can be solved by vectorized operations on fixed size arrays, then you might as well just head off over to NumPy or pandas, because that's where you're going to get your best performance. If your problem is solved by concurrency, well, then you know what to do, and I'm not going to talk about that, or similarly caching as well. I'm not going to make any definite recommendations to you. I might have some advice, but I can't make recommendations to you because I don't know what your particular problem is, and all problems have different solutions. This is not going to be a benchmark comparison of the different solutions. So all the benchmarks you see in this presentation are fake. That is to say, they're just like real benchmarks. Okay, so it might be worth reflecting why this talk even exists. I mean, why do we have to talk about improving the performance? And this is perhaps why Python is how it is. So the reason why Python is allegedly slow, or perceived as slow, is it's obviously an interpreted language. Every line has to be evaled, so every time you go around a loop, the interpreter has to eval the same line each time. It's dynamically typed as well, so the real type has to be assessed each time an object is accessed. It's running on a virtual machine, which is a great way of abstracting away from the platform, but that abstraction comes at a cost, a runtime cost. Python doesn't have a JIT yet, although in Python 3.6.1 there's PEP 523, which opens the door to possibly putting a JIT in, and we'll talk about JIT solutions as well. Python itself takes very little optimization opportunities with the code compared with, say, aggressive C++ compilers. It's kind of interesting to reflect that the first 3 of this list is some of the reasons why Python is slow, but they're also the reason why Python is so productive, why it's so quick to write Python code, and why Python is so valuable. And the second 2 are also perhaps why Python is slow, but they're known to be fearsomely hard problems to solve in computer science. So if this hasn't happened to you already, it's certainly happened to me many times, so your boss comes to you and says, this Python code that you've written is far too slow, you've got to find a way of speeding it up. It's not fast enough. Well, then you've got to ask yourself a number of questions. Is that true what they're saying? Isn't it possible that Python is fast enough for the job you hand? So we're a hedge fund, we trade billions of dollars each day, and we can do that with Python because of the way we trade. Python is fast enough, and then we can take advantage of all the other aspects of Python to make it very quick and cheap to develop new ideas, which is more important to us than speed of operation. If You want to make it go faster. You're not going to try and make it faster overall. You're going to profile it, of course. Profiling it is a bit of a dark art. Profilers often lie. There was a very good talk earlier in a tutorial earlier in the week on profiling that had a lot of good information of it. If you don't, I'd head over to the video there. But get your profiling skills out and decide which bit. And the whole point of doing that is so that you spend the right amount of money in the right place. Because we're engineers, we do things cheaply. Okay, then have a look, of course, at your algorithms. This is a well-trodden path. Are you using the right algorithms? And are you using the right data structures? People often overlook that. I was involved in a problem recently where people were building very large lists of Python objects and adding to the list. And of course, they fail to appreciate that the list has to be contiguous in memory. And when you start adding stuff to it, it becomes a point where it has to be copied and a new memory found for the whole contiguous list. This is a very expensive operation. Having something like a deck, which is like a linked list, has made it much more efficient. Just changing that data structure made a big difference in the runtime. I put up this famous quote at the bottom. Okay, do remember that when you're changing your code. Have that burnt into your memory. So much for the introduction. I thought I'd talk about the kind of options that you have, technologies that exist out there for speeding up your Python code, and how we can kind of categorize these to make more sense, because there is a huge amount of choice out there. Here's some of the projects that are aimed particularly at making Python code or code that starts with Python run much faster. I'm sorry if your favorite project isn't up there, but you can add to it later if you tell me. But when you're considering any of these things, it might be worth starting, well, what would the perfect solution be? What would we really, really like as a solution to making Python go faster? And so, well, here's my kind of wish list here. This is perfection. It can run my Python code directly. I don't have to change the code at all. Okay, so there's no effort by me because I'm quite a lazy programmer. I don't want to change my code, so the perfection would run my code directly. There'd be no maintenance overhead on my behalf. It would work with all Python versions, all library code, all the standard library, all third-party code that I was using, my own libraries and so on like that. It'd be free, of course, fully supported, wouldn't have any bugs in it. It would have a perfect debug story. And it'd be 100 times faster. You'll notice I'm not being greedy with this shopping list. I could have said 1,000 times faster, but I'm going to stick with 100 because I know that's right. So this is what I wish for. So the thing is, this doesn't exist, okay? There's solutions out there that exist parts of this list. So this is where you're going to make the trade-off. If you're going to go for maximum performance, you're probably going to incur some cost, or your debug story might go to hell, or something like that. So it's worth reflecting on what would be perfect when you really make those trade-offs, and just blindly choosing one solution, you're implicitly making those trade-offs, and if you don't realize them, you might get in trouble later. So the kind of taxonomy I've chosen is basically about how much code do you have to change before using that particular technology. I divide it into basically little or no code change, some small amount of code change, or really rewriting your code in a completely different language. So let's have a look at what exists for the first one, little or no code change. There's 5 projects I picked out here. Obviously, it's Python itself. There's a lying benchmark at the top. Typically, these projects will give you 1 times to 8 times speed up. It varies enormously depending on the problem. First, we have Python. Then we have Cython, which is a very well-known project. And we're going to write Cython not optimized code, and I'll show you what I mean there. Then we got PyPy. There was a very interesting PyPy talk yesterday, and I think there's another one tomorrow. I urge you to look at those. This is a very interesting solution. And we got another couple of projects called Shedskin and Python. We'll have a look at them briefly. Okay, so first Cython. I'm going to write some code here, give it to Cython and see what happens. This code computes a standard deviation of an array of floats. Okay, so I put it into Cython, so I run it in Python, it's slow, and I put it into Cython and expect Cython to work its magic. And Cython goes about 1.3 times faster, which is really no performance improvement at all. So Python is rubbish, isn't it? Cython is rubbish, isn't it? It's not a solution at all. Well, it's kind of interesting to see why Cython struggles at this point. It's actually because we're not helping Cython at all. If we just take that one line here, where we're computing the mean, and we look at what Cython does is, so the way Cython works is it takes your Python code, it generates C code, compiles that, and off you go. And if you look at the C code for that one line, here's Cython C code, here's the line that we're talking about. And if we dig down through this rather complicated code, we see that this line, sum divided by len, is expressed by these three calls into the CPython API. These calls are highly generalized, they're highly non-specific, they're not specific to any type. And the reason why Cython can't make an improvement or much of an improvement on our code is because we haven't given Cython any type information. We'll revisit Cython in a moment to see what happens when we can fix that, because that involves changing our code quite a bit. The next one is PyPy. So typically their benchmarks are 7 times or so the CPython implementation. It's a just-in-time compiler. It's fairly drop-in replacement for 2735 code. It doesn't really have a CPython API, but it supports CFFI, Common Foreign Function Interface, which I'll mention in a moment. So that's your way into C and C++. It's not completely compatible with certain libraries. I think Flask and Pillow are a couple of libraries it can't manage. But there's a very good, interesting quote at the bottom of the slide here that should make you pause for thought, although it does have the word probably in it. I guess what I'd say is I'd change that to something like, you should certainly try this, because it has been very successful in some areas. Okay, so much for PyPy. So Shedskin is a project. It basically does automatic type inferencing, translates your Python code to C code. It's quite elderly. It only supports up to Python 2.6. And there's been very little activity for the past year, so I'm not going to delve more into that. And there's also one Piston, which is an LLVM-based JIT compiler. Now this was backed by Dropbox, or I should say was backed by Dropbox. It's only Python 2.7, and the project was suspended in January this year. Now, I offer these last two ones just as an example of one of the problems you're going to have. When you choose a particular technology to go for performance, you're making quite a committed move to that technology. And then if that project just runs into the sand and stops getting maintained, then you've suddenly got a load of technical debt. This is going to be important when we look at the evaluation criteria for which project to use for your code. So much for a little code change. Well, what happens if we accept there'll be some code change? We can make some code change to accommodate these projects. What options do we have there? Well, here's some, and now we get a speeding up of typically sort of 10 to 100 in that kind of range. So we got Cython optimized, we got Number, Parakeet, Python. I'll go through them. So with Cython optimized, basically you do this kind of thing. So on the left is the standard deviation code, which was like the Python code, and I just lobbed that into Cython and didn't get very far. On the right is much more heavily optimized Cython code. And now what I've done here on the function at the bottom is I've actually declared I'm going to use NumPy arrays, so I import NumPy, and that gives Cython a whole load of opportunities there. I'm declaring the local types as size t and so on like that. I'm putting a decorator on there saying don't check the bounds of this array, which is obviously a cost. Right at the top, I'm importing from libc, the math library, and I'm going to use square root from there rather than the Python math square root, which is probably much slower. So if I do this in Cython, I get it running 62 times faster, which is like a really good improvement. It's a fantastic improvement. But consider this, how maintainable is the code on the right versus the code on the left? And we're talking about a really simple operation here, square root on an array. So this is what I mean about trade-offs, is that if you really want that 62-fold performance improvement, implicitly you're going to put up with a maintenance problem, and probably your code is much more complicated than the standard deviation. So Cython, optimized Cython, can rapidly become fairly unwieldy because it's this really weird hybrid code. It's not C or C++, it's not Python, it's this in-between thing. And there's quite an art in tuning Cython to get the maximum performance out of it, and it's a bit of a black art, and that often isn't shared in organizations. So, on to Number. This is backed by Continuum Analytics, which is always good to have a good backer. It's a JIT compiler. It works, it's pretty much aimed at Python and NumPy, and basically you just annotate your functions with a JIT, and this brings in a whole load of JIT technology, and you run it, and the JIT will get to work and try and optimize that based on what it's seen in the past. There are a number of these JIT compilers. One of the early ones was Parakeet, which is still around. Okay, same kind of idea, you decorate your code, and it'll provide a JIT for it. Parakeet is quite old, only supports Python 2.7. It's very much aimed at NumPy. It's quite effective with that, but there's been little activity over the last 4 years. So if 4 years ago you thought Parakeet was the best thing and you started writing all your code around it, then I'm sorry for you now. So Pythran is another one. They use a slightly different technique. They basically annotate the function with a comment, and you can see the types in the comment there. Then you basically run it through Pythran, generate C++ code, and then you run that. It really aims at scientific computing. It's kind of a subset of Python that it interprets, but it can produce really powerful high performance at some cost. So that's sort of some code change section. The third alternative, if you want really high performance, is to basically write in a different language, okay, like C++ or something like that. So what kind of projects are out there that do that? And this is where you really get this kind of like 100x performance improvement, typically, even better maybe. Here are some of the C++ based ones. We have the original CPython C extensions, which we'll talk about in a moment. There's various ones there. There's too many for me to go through, but I'm going to cut it down a bit. And there's also Rust and Fortran and Go and that kind of thing. If that's your thing, absolutely go for it. Okay, I'm not going to talk about any of those. But let's just look at some 3 of the C++ based ones, which is writing a C extension, CFFI, and PyBind 11. They all take different approaches to basically the same problem, is how do you get into writing in C. So firstly, the classic C extension, and these give you a mixture of joy and agony when you're involved in C extensions. So what's the joy? Well, it's written in C. C is really easy. There's only 32 keywords in C, so what could possibly go wrong? You can mix it with C++, that all works nicely. You have really precise control over your performance at this point. And there's a lot of good libraries at AHL. We use this a lot because C extensions can call into NumPy, address it directly as C, and that is incredibly efficient and fast. If you're writing for the standard library, you have to be here because, strangely enough, well, not strangely enough, but the standard library requires you to write in C. In fact, C89 with some little extensions to C98, I think. So here we are in 2017, and we're stuck in C89, which is very interesting for me of my background. Anyway, so that's the joy of writing C extensions. Well, what's the agony? Well, this is a little class. Probably the first class you wrote in Python was something like this. This is taken from the Python documentation from the tutorial about how you write your first C extension. And basically we make a little class that contains a first name and a last name and has a method where you can pull out the combined names. That's it in Python. What's it like when you write a C extension? Well, it's this. It's 190 lines of C code addressing a very complex and sophisticated and well-documented API. Okay, and apart from the fact it's a lot of lines of code, where is the real agony in this? Well, here's the real agony. It's in C. And you have to do reference counts, get your head around that. You have to do manual memory management. You have to understand how Python does its memory management. It's a very specialized skill writing in this C API, and it's quite expensive to write 190 lines versus a handful. Testing is real problematic with Python modules. I'll return to that in a moment. Debugging a C extension is kind of a real black art as well. GDB works fine. If you want to hook up an IDE, if you like debugging an IDE, that can be done. It's a bit tricky to set up. Just to show how it can be done, here's a screenshot of debugging a C extension in Xcode on a Mac. There's a link there to one of my projects that show you how to do that. So if we don't like doing C extensions, or we find that far too painful, okay, what are the alternatives? So here are different languages. So let's move away from Python C extensions and have a look at CFFI, which is a really interesting project, and there was a talk yesterday about it that was very good. I'll give you a list of the talks that I thought were valuable here later on. So CFFI, you're writing in Python. It allows you to call C code from within Python, and it's C-based, but you can also hook up to C++ for a little bit of work. But it abstracts away much of this boilerplate, those 190 lines of the C extension, which is basically the interface code, and it also abstracts away the kind of build system. So if you remember, this is what we were trying to do. This is what we had to do in C extensions. This would be a sort of fairly crude CFFI equivalent. I'm importing CFFI. I create this CDEF with a string in it, which is actually C code. That gets compiled up. I create a new one. I can assign those first and last names to my own name, and I can extract them out in some fashion there. And that code all now fits on one slide, and it just works, and it's been executed in C land. So a different approach is PyBind 11, which I think is also a fascinating project, and I think there's a talk tomorrow about PyBind 11, which I'm definitely going to go to see. So how does PyBind 11 work? It's a header-only C++ library, so you're writing in C++. It makes it very easy to write these C extensions. It's kind of similar to Boost Python, if any of you have used that. And wonderfully, it's C++ 11, so it's kind of a modern version of C++, a kind of easy-to-write version of C++. So here we go. Here's, just to remind you, this is a class we're trying to create. This is what we had to do in a C extension. This is how PyBind works. We're in C++. We create a struct where it has a constructor. It has a single method name, which will concatenate the names. It has a first and last names as members. And then you import, you include PyBind 11, and that gives you access to a whole load of functionality, templates, and macros that basically the creating of the module is just those 4 lines at the bottom. Okay, very interesting project. Okay, and now you've got your shared library that you can run. Very interesting project indeed. So that's all I've got to say about those things. There are other C and C++ ones, so choose the ones that suits your shop. I just say that if you are working in a separate language like C++, try and arrange your code to look kind of like this. So on the right is all your C++ code, for example, that doesn't include python.h. So it might include something else, but it's pure C++ code if you like. On the left is perhaps some Python code that wraps this. Okay. In the middle is kind of like the glue code. It's like the C extension code, or it'll be the PyBind 11 code, or it'll be the CFFI code. And the problem is the bit in the middle is the one that's really hard to test. So if you can physically and logically separate the code in the left and the right as far as possible, you can then test them independently for correctness and performance, because performance is what we're after. If you put too much code in the middle, it effectively becomes untestable. So I'd recommend some physical and logical layout that is something like this. So that's basically the taxonomy, which was the second sort of section of this talk. Now I want to talk about the evaluation criteria that you might use to judge which of these solutions is suitable for you. So again, here's the choice you make. So how do you, we might be able to divide these up now with this taxonomy and understand which is the one that would give us the right trade-offs, but how do we evaluate even within that taxonomy which is better? So I suggest that there are 3 kind of areas you need to consider when evaluating these, which are this. It's basically who you are, what company do you work for, what organization is it, what team are you in, what skills do you have, so on and that. Then there's technical criteria. We're probably mostly engineers here, and we like technical criteria because we can put numbers to them, and numbers are our lifeblood. But there's also non-technical criteria as well. I'd argue that are equally important when you make a choice. So first of all, who are you? Well, I'm guessing a bit here, but I'm guessing you're not Facebook or Google or Microsoft or anything like that. So these companies do a lot of interesting projects, and they publish white papers, and they open source stuff, and they say, we're using this particular project, and it's really fantastic for us, and so on like that. And the temptation is because they're using it that you should use it. But you're not them, okay? They have their own problems, which may not be your problems. They have their own culture, and they're constrained by that, and you have your own culture, and you're constrained by that. You may not be constrained by what they do. So understand what they're trying to do and what you're trying to do are different. So don't be too overly impressed just because one of the big companies is doing it, that's what you should do. On the other hand, because a big company is backing something, that is also a plus for a project because it's likely to increase its longevity and quality. So consider also what skills you have to maintain this code, or what skills you can get, or what skills you might lose as an organization. Because if you've gone down the route, for example, of highly optimized Python, and you've got a couple of people that got really skillful at doing that, and your whole code is running really smoothly, if those 2 people leave, then you've kind of now got a whole load of technical debt. So let's have a look at some of the technical criteria. We're fascinated by this stuff as engineers, what we might look at. Okay, these are things that we can put numbers to and compare two different options against each other. So what might there be technical criteria that we might look at? Well, what do these projects depend on? Do they depend on things that we don't really want to depend on, or different versions that we don't want to use? We can put numbers to that. What versions of Python do they support? As we've seen, some of these projects only support older versions of Python. Some of them struggle to make the transition to Python 3. Some of them only support part of the core Python or part of the standard library, and some of them, perhaps the third-party libraries that you might depend on, aren't supported at all. You can go and find that out and compare alternatives very easily. And then finally we get to benchmarks. Of course, people are obsessed with benchmarks, or perhaps not obsessed, but benchmarks carry a lot more weight than I think they deserve, mainly because they're kind of wrong, and as I said, all the benchmarks you'll see here are lies, just like real benchmarks. So what are the kind of the obstacles to benchmarking accurately to make rational decisions about various options that you have? Well, there's simple measurement errors. There's just measuring the wrong thing or measuring in the wrong way. Bad statistics, and I won't go through the whole of benchmarking. There's loads of good material out there about how to benchmark properly. Bad statistics is an interesting one because in benchmarking, you're going to take a small subset of results and then you've got to reason about the wider world with statistics based on that small set. And if you do bad statistics, we'll look at a couple of examples in a moment, then you're going to mislead yourself with benchmarking. And then there are actually human cognitive biases, confirmation bias. You might be overly fond of one library, and therefore you might implicitly be starting to look for positive benchmarks in that library, or you might get fixated on one small part of the problem, ignoring the wider aspect of the problem. So these are all obstacles to objective benchmarks. So here's some benchmark pitfalls I'm imagining here. We're running a test 8 times, and we got library C and we got library D, and we're comparing them. And lo and behold, we're taking the average of the timings of them, and we're being very good statisticians, and we're taking the standard deviation. And lo and behold, they come out the same. So it looks like library C, library D are exactly the same. But if you look, library D has an interesting pattern to it. The first time you run the test, it takes 18, and the subsequent times it's a very consistent 8. This is maybe characteristic of some kind of JIT kind of behavior, and so I'd say that if you're running this in production many times, that library D is definitely a better choice. If you're only going to operate that function maybe once, then it's probably the worst choice. So you've got to look at the trends as well as the raw data. Here's another common fallacy, is I got a number of tests here, independent tests of 2 libraries, G and H, and I'm combining them, taking the average, and the average looks like they're the same. Okay, but if you notice, the tests take widely different times, and it's actually quite misleading to take the average. If I add another column onto it, where I divide H by G, you'll see that in the first test, H takes slightly longer proportionately, but in all the other tests, it's twice as fast as G. So how come the average is so misleading, saying they're the same? It's because what you need to do when combining widely different numbers is take the geometric average, not the arithmetic average. Geometric average is the product of all the numbers divided by the nth root. And now, we see, if I take the geometric average, that library H is much faster than library G. In fact, tables are a really bad way to present benchmarks as well, because they're just numbers. Here's a much better way of presenting a benchmark. This is a real world one, not from the company I currently work for, but basically this is a graph, and on the y-axis, on the x-axis, it's logarithmic. It's a file size going up to 100 megabytes. And what we're doing here is, this is a sequential file, but we want to randomly access it. And so we're creating an index by read-seeking through it, find the interesting points, and then we can randomly access it much faster than a sequential file. Now the red dots are the original Python code on the top. Oh, sorry, the y-axis is how many milliseconds per megabyte of file it takes to create the index that we want. Okay, the red dots are the original Python implementation, and the green dots are writing it in C. Now, there's a wealth of data in this file. For one thing, you can see there's a big range of inputs. The file sizes we're testing are from very small to very large. There's about a 2-decade improvement, general, on the C code. The fact that it flattens out means it's ON. And then there's some really interesting stuff happening with some outliers up the top and reflected in the bottom. If you look at the bottom right-hand side, there's some files remarkably are taking much, much faster than others, even with the Python code, and that's reflected in the C code as well. And when we investigated those files, we found another technique, because they had a particular property that we could exploit for all files that gave us another 10x improvement. So presenting data like this gives you a whole wealth of information that you can make reasoned decisions and compare that with a table, how much information you're going to get out of that. Okay, if you're benchmarking, don't just do speed. Here's a great long list of stuff you should do because memory might be more important, or I/O. What are the trends of benchmarks? And once you benchmark, do you put it into production and forget about it? No, you want to be benchmarking your production code as well. So the last thing in evaluation is like the non-technical criteria. So these are things that you can't put numbers on. Okay, and sometimes engineers shy away from this because you can't put a numeric value on it. It's a bit of a harder decision. I'd argue it's equally as important. So here's some non-technical criteria you probably want to consider. Ease of installation deployment, if it's a large deploy. Again, dependencies. Ease of writing the code and maintaining it. What's your debug story? What's your tool story for analyzing your code or reporting things out of production? And is the project that you've chosen, be it PyPy or Python or whatever it is how future-proof is it? And that's a really difficult judgment call because, of course, the past is no guide to the future, but it's all we got. So how can you try and predict whether a project, because we've seen several projects that just suddenly halted, so let's hope that your solution doesn't do that, leaving you with all that technical debt. These are the kind of things you want to look at probably, is what Python versions are supported, are they moving up versions in a timely fashion, what's its development status. If it's old, that's maybe a good thing because it's been around for a long time, it's mature. On the other hand, it might be using very old technology. A newer project might use more newer language features and be better than that. Is it maintained? Do they have good, interesting backers like a large company or a determined company? Fixes quick? Do they take PRs? That kind of thing. Also, who's using it? And interesting enough, is there a consultancy around? Because if there's money to be made, if there's money swilling around a project, it's more likely it'll last than one that's just been given out for free and everyone's taking it for free. So those are the kind of 3 sections that I have for you. So I'll just finish up by just making a summary. This is what I kind of say as the takeaways for you, is just choose these, out of these solutions, choose the solutions that's appropriate for your organization, your skill set, your product. It's your choice. Just recognize that you're going to be making trade-offs. And if you don't realize that, there'll be implicit trade-offs that could come back and bite you. So try and be explicit about what you regard as important. Benchmark if you must. Benchmark wisely when you can. And I'd argue that these non-technical criteria are equally important for the longevity of your code than the technical ones. Just as a shout out, I'll just make a shout out here for this book. I have nothing to do with this book at all, except I know one of the authors slightly. But it's High Performance Python. I got quite a lot out of it, and I recommend it if you're, it covers a lot more territory than I'm covering in this talk. But if you're interested in High Performance Python, this is definitely one to go and get. And also, just don't listen to one person, particularly me. I mean, consider other opinions. Here's some of the talks here in EuroPython. Monday and Wednesday, we had some of these talks I went to. I got a lot out of them about CFFI, profiling, Python, so on like that. Tomorrow, we got 2 talks. I'm definitely going to go to one on C++11 and the other one on PyPy. So listen to a lot of opinions when it comes to performance, not just one. And that's about it, and I'll answer your questions as best I can. This is, if you want to stalk me on social media, this is about as far as I get on social media, which is GitHub, also AHL. We open source quite a lot of our code now, some very interesting projects there. I urge you to go and have a poke at that. And you make my bosses very happy if you had a look at our Twitter feed, our work Twitter feed. And that's it from me, so I'll try and answer your questions as best I can.
Thank you for the talk. questions?
Any tip how to get around the confirmation bias when testing? Because this is very difficult in the culture in the team.
How do you go around confirmation bias? I suspect humans have been struggling with this problem for millennia, really. I don't know. I think it's... I think when you want to present material to persuade other people, you have to kind of make that material falsifiable. There must be enough information in there so that someone can form a contrary opinion. So if you just say this is faster, you're not giving anyone any purchase to say, they can't deny you because you're not giving the information. If you say, I believe this is faster and here's the data for it, you're giving them some sense of falsifiability because they can look at that data and say, oh, you're taking the arithmetic mean, not the geometric mean, and therefore you're drawing the wrong conclusion. Okay? So I think some of these biases, some of these cognitive biases can be helped by presenting your information to a large number of people, and they might be able to spot something that you can't spot yourself. Because it's very difficult to avoid confirmation bias yourself, but perhaps if you're aware about it and you ask yourself that question, that may help as well.
Hey, thanks for the talk. Considering two main technologies for binding, namely PyBind 11 and Cython, what is your view regarding advantages and disadvantages of each one of them?
Okay, well, I've used Cython quite a lot, both on my own projects and at work. We depend on it quite well. It is one of the most mature projects out there. It's used all over the place. Another standout example would be Pandas, heavily depends on Cython and so on like that. So it's got to be a star. The PyBind 11 is a much more newer project, but I think it's very interesting because perhaps it addresses some of the issues that I've come across from time to time with Cython. Certainly, like debugging in Cython is really quite can be quite a challenge. The fact that Cython optimized code is in this strange sort of hybrid form, I understand why that would be so, but it also makes it kind of hard to read and reason about. With PyBind, apart from the bindings, you're pretty much operating in C++, which should be easier to reason about. So I think it really depends on who you are, what your capabilities are, that kind of. If you're a strong C++ shop, for example, then PyBind 11 would be a very interesting route to take. Although Cython also can lock you, can get you into C++. I'd say performance-wise, there's probably not a big deal between them, but I have noticed sometimes with Cython-generated code that you can make small changes in the PYX file, the Cython file, and you get radically different changes in performance, which are not necessarily predictable. And it's just the way they use a lot of heuristics to generate their C code and some of those changes. And that's often noticeable between versions as well. So I think they're both very fine projects, and I think it probably comes down to there's probably not much to choose between them for performance, but it very much depends on what kind of shop you are, really, and what your personal preference are. I don't think you'd be wrong to choose either one of them.
Going back to your graph on the file read.
Sorry.
Going back to your graph on the file read performance, you mentioned that you identified something there that actually resulted in a 10-fold speed increase for, I believe you said, the native Python code as well. Can you just comment on kind of going down the rabbit hole of optimization? And, you know, as programmers, we love new and challenging things, and maybe we see a problem and we think, oh, you know, we should implement this or anything. Do you have any tips for how we can avoid, you know, going down a rabbit hole where maybe a 10x improvement, but keeping it in native Python would have been enough?
Yeah, well, I guess this, I think there's 300 data points on each of these, and it turned out there was something like 8 or so data points, which are these kind of outliers, which you kind of at first sight might think are just statistically not significant. But we did go and actually have a look at them, and we found an interesting thing. So this is basically a sequential file where a series of records are written one after the other, and to read to any point in the file, you have to read everything up to it, because they're variable length records. Okay, and so you can't just go into some place. And the reason for conducting an index is at the index at the start of each of these variable length records. Well, it turned out that most of them, the variable length records, had a maximum size of 1K. So there were lots of small records in there. And it turned out the outliers had a record size of up to 64K. So there's much fewer records, so creating the index, you're doing much more seeking and much less reading because you have to read a header of each one. So that accounts really for the kind of 10x improvement. And what we realized, we could actually rewrite all the files from 1K records to 64K records. And that was how we got the extra 10x improvement. But without it being presented in a graph like this, and without kind of like the curiosity to say, ooh, those outliers might be interesting, and I'm not going to dismiss them, we wouldn't have found that 10x improvement. So I guess we could have gone down a rabbit hole because it could have just been statistically significant, but we did start off by doing a little bit more statistics, a few more runs and that kind of thing, and discovering these were actually real outliers rather than just statistical anomalies. Our rabbit holes are something that I seem to merrily dive into, I'm afraid, so perhaps my advice on backing out a rabbit hole is more one of experience than of good decision making.
More questions? We still have a couple of minutes. A few. Nobody? Everybody's happy with their code's performance?
I've been using Boost Python.
Yep.
And it has two downsides, which are the fact that the compiles take a long time, and it sometimes produces very big object files. So is PyBind 11 improving on these metrics?
Yeah, I'm probably a bit outside my zone of expertise here, so this is probably some speculation. But I haven't used Boost Python for quite a long time. I really admire the Boost project, but it's getting on quite a bit now, and it is kind of got all sorts of stuff that probably reflects history rather than modernity. And PyBind 11, from what I understand from the authors, was really was inspired by Boost Python, but it was a complete kind of refresh, starting writing afresh the whole thing, and in C++11. Which would make me think that given a modern compiler, you would get less variability with PyBind 11 than with Boost. So it might be worth, I certainly recommend that you go and look at PyBind 11 and see if you get the same kind of problem, but I'm not going to predict whether you would. My guess is that you wouldn't perhaps get that problem with PyBind 11, but I'm speculating a bit there. But I'd recommend you go and try.
Okay, so thanks for the talk and the questions. Give another warm hand to Paul Ross. And as usual, please remember to rate the talk and give some feedback to the speaker and the organizers. Thank you.
it will work, but I'm not sure. So the plan is very simple. I will start with network visualization, and I will end with network automation. But before I start, I want to make a short introduction into networking, like a crash course in networking for those of you who don't know well what it means. So when I say network, what I mean is a telecommunication network. It's a network which nodes are networking devices like routers, switches, and antennas, and a network which links are transmission links, usually Ethernet cables and optical fibers. In the network of an internet service provider, we find three main types of nodes: router, optical switch, and antenna. As you can see, these are very big devices, like with lots of cards and lots of interfaces. So this has nothing to do with the type of device that you would have like at home. These are corporate devices that we would find in the network of a big company like Facebook or Google, or in the network of an internet service provider like Vodafone, Telefonica, and so on. Same for the transmission links. These are links like those ones. On the left, an Ethernet cable with a 10G capacity, a 10G connector, and on the right, an optical fiber. So Ethernet cables are used for short distance transmission, and optical fibers can be used for both short distance transmission and long distance transmissions. Well, there are a few approximations in this slide because it's like to make it simple for you to understand, but if we imagine that you are in Rimini and you want to call someone in France, like with your mobile phone with a 4G, what would happen is that like your mobile phone will send a microwave signal to an antenna that should be located nearby, like close to this Pala Congressi, and then the signal will travel through a bunch of antennas. It will be a microwave signal, and this microwave part with antennas, we call it the microwave backhaul. Eventually it will reach a router. A router is a device that will take the forwarding decision. What we can say about them, it's like the brain of the router. They know how to reach any part of the world, and they will make the forwarding decisions. They will know which path the traffic has to take. In order to do that, the router has what we call a routing table, which is a table that associates an outgoing interface to an IP address. And finally, since we want to go to France, which is very far, we need the signal to go very fast. So the router will send the signal to what we call an optical switch, and this optical switch will perform an electrical to optical conversion, which means the signal is electrical at first, and it will become a wavelength, which is a stream of light. And on top of that, in a single fiber, we can have usually up to 88 wavelengths, so 88 stream of lights, and this is a technology we call wavelength division multiplexing, which is used to have very high bandwidth capacity. When we buy network devices from a vendor like Cisco, Nokia, Huawei, they usually provide what we call a network management system. It's like a software or a web application that can be used for network visualization, inventory, provisioning, supervision, and sometimes automation as well. It's a network that has like an overview of the network of all devices. If we want to visualize our network, the input file that we have is usually a network topology. It could be like a CSV file, Excel file, a text file. Basically, it's a file that will contain the list of all nodes and the list of all links and the position of the nodes as well. So if we want to draw this network, as you can see, if we draw like nodes at random positions, this doesn't yield a very good display, so we have to find other ways. We have basically two options. The first one is to use The first one is to draw the nodes at the physical location where they are like physically located by using GPS coordinates. To do that, we use a type of software that we call GIS software, which stands for Geographic Information System. And that allows us to, the idea is to draw maps and draw our network devices on this map. And the other option is to use a graph drawing algorithm. I will make a demonstration of both if it keeps working. So what I'm going to show now is how we can create a simple GIS software in Python, so a software to draw maps. The first thing that we need is a GUI programming framework. We have a lot of such framework in Python. We have PyGTK, PyQt, WXPython, PySide, but the one I'm going to use is Tkinter. It's Python interface to Tcl, and it's the only GUI framework that is like part of the standard Python distributions, which means you don't have to pip install anything. It's by default, it's a built-in module. Inside that framework, we will need a widget for drawing. All widgets have one. In Tkinter, it's called a canvas. It's basically a widget that allows you to draw circles, rectangles, but most importantly, polygons. And we will use, inside that widget, a method to draw a polygon. The reason for that is that a map is actually just a set of polygons. If you look at Italy on this slide, Italy is just like a polygon. It can be considered a polygon. So to draw these polygons, we need to have coordinates, and we will use a special type of file which is called a shapefile. A shapefile is a file that contains shapes, and the shapefile that I'm going to use contain two types of shapes, polygons and multi-polygons. These shapes are described like as a list of coordinates, as a list of points on the Earth, and a point on the Earth is defined as a longitude and a latitude. So the first library that we will use is called PySHP. It's simply a library that allows us to draw, to extract the shapes from the shapefile. It contains a reader object that we can use to read the file. We can draw polygon with the create polygon method in Tkinter, but as for multi-polygons, we cannot draw them. We can only draw polygons. So what we will need to do is to convert all the multi-polygon is actually just a set of polygons, and we will need to convert a multi-polygon into multiple polygons in order to be able to draw them. And to do that, we will use another library called shapely. When you use shapely and you convert a shapefile multi-polygon into a shapely multi-polygon, it will actually make the multi-polygon iterable, which means it will have this double underscore iter function, so that you can loop over the multi-polygon to yield all the polygons it contains. As I've said, shapefiles contain coordinates defined as a longitude and a latitude, and if you look on this slide, you will see that these are angles. But when we draw polygons in a software, in a canvas, we cannot use angles. We need pixel coordinates. So we will have to make some kind of conversion from angles to pixel. This is actually a conversion from 3D to 2D because we have a point on the Earth and we need to have a point on a plan. And this is what we call a projection. So there is a mathematical theorem by Gauss that basically says that if you make such a projection, like you have a sphere and you want to project this sphere on a map, it's called the remarkable theorem, then you will lose some information in the process. There will be what we call a distortion. It could be a distortion of distance, of angles, of shapes, any distortion, but we will lose some information. For instance, if we consider the Mercator projection, it preserves angles, but it doesn't preserve areas. In order to make that projection, to convert 3D coordinates to 2D coordinates, we will use another library called PyProj. It's a library where you can choose a type of projection. It could be Mercator, or it could be azimuthal orthographic, like you see on this slide. And we will convert a longitude and a latitude into pixel coordinates. So if I sum up, we need a GUI programming framework. We will use Tkinter. Inside this framework, we will need to use a widget to draw polygons, Tkinter's canvas. We need a file that contains the coordinates of the map, a shapefile. We'll use PySHP to read the shapefile. We'll use shapely to convert multi-polygons into polygons. And we'll use PyProj to convert geographic coordinates into projected coordinates. So, okay. Okay, well, I will open a Jupyter notebook to show you how it looks like. So, okay, so, well, this first code shows you how to initialize Tkinter main window and how to initialize a canvas, and finally how to use the create polygon method in order to create the polygons. If I start this code, I will get this, which is like a graphical interface with a polygon. Finally, I have this snippet to show you how to use PyProj. We need to initialize a projection. This EPSG code, like 331995, stands for the Mercator projection. Then I have the longitude and latitude of Rimini, and I can use the Mercator projection to convert longitude and latitude into projected coordinates. And I can use this inverse equal true to make the reverse operation, which is convert projected coordinates into geographic coordinates. And if I run this code, I print the coordinates, we can see that we have the xy and longitude, latitude. Then I show you how to use the shapefile reader and how to import shapely. So I have this local path to a shapefile, and I will start with a reader object. I will extract all the shapes from the shapefile, and when I loop over the shapes, I will convert all of them into shapely shapes, so that multi-polygons are iterable. Like this. You see that I have this Azatre shape magic iter, and it returns true, so all multi-polygons are iterable. And finally, this is like, well, the final code that shows everything, how to start Tkinter, I give the local path to the shapefile. I have this two projected coordinates function in order to convert longitude and latitude into projected coordinates. I will read the file, extract all its shapes. I will loop over the polygons, convert them into shapely polygons, and finally I will use the create polygon function. If I execute this code, I get this. It's very simple, but it's working. And I can improve it a little bit by, I can change the projection here to have an azimuthal orthographic projection. I will create a circle which radius is the radius of the Earth. And I will use TechInter file dialog so that when you run the code, TechInter will actually ask you to choose a file and it will then draw it. So if I run this code, it asks me for a file, and if I draw it, I get this. So this is very easy to do in Python. As you can see, it only takes like 30 lines of Python to get this result. So what I want to show now, if it works. No, it doesn't work. Okay, so I will actually use this method in order to import a real network. I will import project. This network file contains a real network. It's actually one of the main French backbone. You will see in a few minutes. Okay. So if I import this file, okay. So this is one of the main French network. It is made of about 350 optical switches. In case you're interested, these optical switches are Alcatel-Lucent Photonic Service Switch, or PSS 1830. So basically, if you are in France and you're trying to use internet with your mobile phone or with your computer, well, there is a chance that the signal you send will actually be transported over this network. Of course, if I wanted to do just visualization, I could use frameworks like, I could use a Google Map API, I could use GeoDjango, or I could use D3 also, if I wanted to do it in JavaScript. But the reason why I want to use an actual software is that I can select some nodes, I can move them, I can delete them, I can create new nodes with a drag and drop system, so I can like actually create a network, and I can look at the property of the node. For instance, if I put the IP address here, okay. Well, I can say like this node has this IP address, and once this is done, I can hopefully start an SSH connection to the device like this. Okay, so the device I'm using, you don't see it from there, but it's actually just here on the ground. It's a Cisco 1841. Well, it's back. Okay, so I'm connected to the router. There is a few things that I want to show you. The name of the router, it's called router 2. It's what you see on the left part right here. So this is what we call the host name. If I want to change it, what I need to do is to enter the configuration mode by writing configure terminal, and then type hostname and the hostname I want, for instance, Rimini. And when I do that, you see that the hostname, the left part, is changed to Rimini. So what I'm going to do now, Well, the idea is that if you have like 5,000 devices and you want to change the host name on all 5,000 devices, you cannot possibly log into all the devices like by hand and change the host name yourself. So you need to automate this process, and we can do this by using Python. So I will come back to my slide. Wow. Okay, so this is a slide, this is an overview of the network automation landscape, which is all the methods you can use in order to automate the network. The first one is the one that network engineers have been using for many years. It's simply to connect to the device with a library such as Paramico. Paramico is the default library in Python to start SSH connections. But Paramico is very complicated to use. So network engineers have built other libraries on top of Paramico in order to make it easier for network engineers to automate. The two most famous libraries are NetMiko and Xscript. Finally, you have also the netconf and Yang solution. Netconf is a network configuration protocol, and Yang is a modeling language that we use to shape the data that are sent over netconf. This is standardized by the IETF. I don't want to spend too much time on this one, but just so you know, there was a talk at the last PyCon US in Portland about how to use netconf and Yang. Finally, you can use OSS protocols like TL1 and SNMP with Python library to SNMP, which is called PySNMP. But, well, SNMP is usually very complicated to use. You can also use configuration management tools. These tools originate from the DevOps world, but they can actually be used for network devices as well. So you have Puppet, Chef, SaltStack, HPNA, but you have also Ansible, which is the one that is gaining momentum at the time, and it's an open source Python project. And well, if it works, I will make a demonstration of how to use NetMiko, Xscript, and Ansible in order to automate in order to change the host name. So I will come back to the code. So we can stop, I guess. We can stop here, I think.
You can go on, just they have to check online because everything is online and it's going well. What is you're doing online is going well. I know, I'm sorry, man. I can't do anything really. I don't even know where they are. Now it's coming. That's the thing.
Okay, well, I think we'll stop here maybe.
I'm deeply sorry about that.
Can you try another resolution?
Yes.
1270 for 720. 1, 2.
I will just explain what I would have done. What I wanted to do was to use Xscript, NetMiko, and Ansible in order to show you how to do basic automation. I'm not sure I can still do it. Okay, I'm still connected to the Cisco device. You can see the host name is Remini. And if I use Xscript, so the idea is that I must create an account object in order to give the credentials to connect to the device. I must create a host object to give him the IP address of the device. And finally, I will send all the commands required to make that automation. So if I say hostname friends and I run this code, in a new shell, you see the host name was changed to friends without having to log into the device. So if we had like a lot of devices, what we would use is to multi-thread all the SSH connection in order to configure all the router at the same time. Xscript allows you to do this by, if you loop over the IP address and you create host for each IP address, then you append them to a host list that will contain all the devices that you want to run the script on. Then Xscript will actually use multiple threads so that all SSH connections are done in parallel. And you have this max thread parameter here when you can say, I want at most 5 threads. You can do exactly the same thing with NetMiko. You have this connection parameters dictionary that contains the credentials like username, password, as well as the IP address of the device. You would use this connect handler to log into the device, and you will send all the commands you need to send. So, for instance, what I'm doing here is that I'm adding a description to the interface fast Ethernet 0/0, and I'm also storing the result of show running config, which is the configuration of the router inside a config variable. So if I run this script, it will take a few seconds. Okay, if I print config, I see that config contains the configuration of the router. And if I look at the interface, the configuration of the interface, I see that it has this description OSPF interface. That configuration was pushed with NetMiko. I can also do the same thing with Ansible. I will start Cygwin. So the idea with Ansible is that you have a file called inventory. If I look at this file, you see it contains the IP address of the device you want to send the script to. And you have what we call playbooks. These are this file .yml files. You can look at one example here in order to do the same thing, which is changing the host name. So I will first give the credential to Ansible, and I will then use the iOS config module. And this line's hostname Paris will change the hostname to Paris. So I can do that using Cygwin by writing Ansible playbook. I tell him that the inventory file is inventory, and I change the hostname. Okay, as you can see, it worked. The Ansible script was sent to the device and the hostname was changed. What I can also do is use the iOS command Ansible module in order to send the show running config command, and then I will use copy to store this configuration in a file output.txt. I will also use Cygwin to send this one. So change hostname. save running config. Okay, and if I look at the folder, you can see that I have this new output.txt file, and if I look at what's inside, it contains the configuration of my device. So, well, I had more things to show, but I think we can stop here. Thank you.
Okay, thanks, Antoine, for the talk. Questions?
When you want to use commands that will require confirmation, like, I don't know, reload the router probably will...
Yes. Actually, with Xscript, you should look at the documentation. I don't know if I have internet, but if you look at Xscript documentation, you can tell when Xscript should expect a prompt that it does not recognize. For instance, if you connect to an Alcatel devices, sometimes it will ask you for yes or no, say yes to continue the login part. And you can tell Xscript that if it says yes, then it should understand that this is that the device is expecting something. And that works perfectly.
Hi, maybe
Hi.
you have told us where have you got the data for the geographic representation from?
Where I took the shapefiles?
Yeah, I mean the raw data, where did you get it from?
The shapefiles, you can find them online. I just Googled shapefiles countries or shapefile continents. About the data of the network, that's because, well, I work at the company that runs this network, so I did an XML query to the SAM5620, which is a software that supervises the network in order to retrieve the topology.
Hi.
Hi.
What are the best practices to map like a lot of devices? Devices like mapping influence the host names, let's say, of the IP addresses and the login credential. Imagine you have like 5,000 devices and in your script you just show, for example, that you're using host name and configuration like account and things like that for a particular device.
Yeah. Well, actually the tool I made, I wanted to show it, but because of the technical issues I couldn't. Can do that. That was my next demonstration. If you have like several devices like this, what you could do is, what I did is like providing a graphical interface to Xscript so that you don't have to code anything, it's all graphical. I can go to script creation and I can change the, like, make a script change host name. And then if I write configure terminal and then host name, you would like this part to be a variable, right? Is that your question?
Yeah, let's say you have like
yeah. So
devices the script needs to map.
Yeah. So using this software, what you could do is like doing host name, which means replace this part with the host name value of the property of the device. And you can save this script. Then if you look at the properties, it will look for the host name properties and it will replace the value. And actually the host name properties does not exist yet. So what I did is a way for network engineers to create properties on the fly, even if it does not exist. So I have this, I have a file called change host name, and it contains the value of the host name. And if I import this file like this, import host name, you can see that the property, well, it doesn't work here, but you can see that you have new hostname properties, and it actually contains the value that is in the Excel file. And then what you would do is select all 3 devices like this, and then you click on send a script. You will choose a script, and for each devices, the hostname part would be replaced with the actual value of hostname for the node, you know? This is using Xscript.
Xscript on the backend.
Xscript, but you could do the same using NetMiko, and you could do the same using Ansible as well. Okay. And if you wanted to do this like in pure Python, you would just need to have a dictionary that maps, well, the IP address of the device to the value of hostname or whatever you want,
yeah,
and that would work too.
The question was if you use some vault or some, secret storage, something like that. Because actually those credentials in customer environment are very, important.
Yeah, no, I don't use any secret storage because it was just for a simple demonstration, and well, it's not like, but yeah, you would need to encrypt the data in a real network.
Okay, thanks.
More questions? So is there an Ansible interface for PyNMS?
Is it what?
Can you run Ansible scripts, where it's like selecting a few hosts and right-click, run script?
Actually, I want to add that as a new feature, but right now I'm just working on Ansible, trying to make a useful Ansible script, and then when I get something that's working, I want to make PyNMS like as a graphical interface for Ansible, so that you don't need to actually write the YAML file. You can do it graphically as well.
More questions? Okay, no questions. So let's thank Antoine again.
Thanks.
Ah, ma perché è andato in stand-by il computer? Te a cagare. Non lo vedi? Stacca l'HDMI invece dal loro bocchino. Ah, deve essere qui. Che ho cambiato risoluzione.
Eccoci qua. Salve, buongiorno. Che cazzo sta succedendo? Non vuol sapere, eh? Un cazzo. Tommy, Dio buono. Hai provato, Edith?
C'ho tutte le risoluzioni. Ecco, adesso 720p esce.
Grazie, grazie.
Mi era tanto.
Sono assestato adesso.
Ho sperato 1080, però ecco, correzione impazzisce.
Cos'è che impazzisce?
Però fargli... no, così lo fanno da tutti. Adesso ti fa selezionare in teoria quale output. In base... Ok, così l'ho acquisito. Oh, adesso il computer si è... Adesso vedo VP727. Ok. Perché prima vedevo il distributore, adesso invece vedo il
Dini,
VP. Però...
dai un accendi spegni al mixer. Spegnilo, aspetta, no, devi andare qua. Anzi,
tutto, così anche ti
vai da
dice...
qui, va, tutto? Sì, spegni un attimo.
Fammi.
È il mixer questo. Vado, Vai. Hai spento? Oh, aspetta. Quella porta deve stare aperta, magari neanche spalancata così, però aperta. Io anche ieri l'ho lasciata. Dopo
No, ma anche stamattina era aperta, l'ho lasciato anche io, poi si vede che l'host si è preso la zappettina.
Adesso rubiamo un qualcosa, lo mettiamo lì.
Andiamo?
Sì, sì.
Io ho sganciato 24 ore.
Hai spento. Ma te quanto esci dal mixer?
1900.
Se eliminiamo il mixer?
Prova ad eliminare il mixer all'inizio.
Aspetta,
Sì,
faccio.
proviamo direttamente.
Sì, vediamo se è lui che fa lo stronzo.
Aspetta, sotto i 20.
No, la gancia?
No, agganciato e tieni. Stessa cosa come prima. Prima ho avuto uguale, solo che flickerava cioè sganciava, riagganciava di più.
Prima ti flickerava.
Non mi faceva proprio così tanto, ma mi faceva come adesso questo disturbo, però mi sganciava e riagganciava di più e mi faceva il disturbo.
Bypass mixer, no? Ci vuole una Dexon anche qui. Ding ding. Ding. Nance muy ben sgancia.
Ecco, così mi faceva.
Perché il 720?
720 tiene.
Ah?
720 tiene.
Cos'è? Allora non è mix. Che ti fa questo problema?
Ah no, mix,
Cioè,
perché
qui
entra nel mix.
da questo?
Mix, entra nel mixer.
Possiamo fare una cosa, se siete d'accordo? Facciamo che eliminiamo questo distributore, mettiamo il mixer e vediamo se va su 1920. Se va su 1920 invertiamo TX e RX e li mandiamo la linea a loro dalla linea della regia.
Adesso così, avrei fatto il cambio?
Sì.
Hai staccato?
Ho staccato il mix.
Ah, aspetta. Facciamo così?
Dovrebbe essere.
Che così rimettiamo le cose a posto, che qui c'è poco elastica la situazione. Beastie Beastie!
Ma se mettiamo la matrice lì dentro?
Se ci mettiamo un touch.
1080 non prendo niente.
Andiamo sulla linea.
Perché non va 1080? 1080 fa così?
Adesso non va. Adesso non va. Forse qua. Non ci vuole.
Qui ogni tanto però arrivava una schermata di macchina anteriore sul due.
Sono agganciato. 720.
Perché senza mixer?
Ma quello che è.
No, non ti aggancia, devi agganciare, c'è tutto. Possiamo fare così? Stacca il distruttore. Vieni qua che tu vedi a leggere senza occhiali.
Potrebbe essere sprinterino, perché è un casino con quelle lì. Magari mettiamo un altro più piccolo.
Sì?
Prova a mandare qualcosa, vediamo se è tutto reggo. Assolutamente no.
720.
1080? Mi si è fatto qualcosa.
Input, provare a invertire gli input dei mixer. 1 dal 2. Però qui passo da sto bacino qui. Ah no, uguale. Però...
Mando in proiezione 720 dal disco.
Ah, aspetta, io sto entrando a 1080 però. 720.
Facciamo in 720. E adesso un T serie X, cosa facciamo? Invertiamo questi due o andiamo a prendere gli altri? Invertiamo questi due.
Il punto è che qui però...
C'è quello due canali.
C'ho quello 2 canali.
Lo mettiamo qui e ti mandiamo su quella linea, invertiamo e ti arriva su quella linea il segnale e basta. Ok?
Vabbè, questo lo metto questo, facciamo invertiamo questo.
Però noi dobbiamo togliere il ricevitore. No, devi togliere quelle X che ti arriva. Quelle X.
Il quello lo vuoi, cammina lì? No, non serve. No, non serve. Dimmi Ste? Ah, lo stand by? Ok, ce l'ho. È tutto blu. Qui è 720. Provo a schiffarti 1080?
Addirittura lui avevano due, però. Però c'era uno che... Sì, adesso vediamo. James. Questo qui. Questo smacchio di te.
Che sia il solito sempre tra che stacca la TGA. Non succedeva con il proiettore. Però
Ciao Simo! Sì, scusami per l'orario, ma sono qua nella sala dell'Arengo, no? Che abbiamo sistemato un po' di robine, abbiamo cambiato un po' di cose. E l'unica cosa è che ancora adesso è rimasto che praticamente non ti acquisisce le slide qua nello streaming. E allora io stavo un po' smanettando adesso qui, però non volevo neanche... Esatto, non acquisisce le slide. Non, qui da te. Se c'hai qualcuno che lo so che sta mangiando, però se riesce a ripatriare. Sì, abbiamo tolto il killer, abbiamo tolto.
Cioè, mettiglielo lui, qui.
Ciao! Ascolta, io qui...
come la prima, vai passando.
Sì, ma adesso l'ho tolto il killer da lì e praticamente sto facendo una nuova mandata. Io per vedere per bene quelle slides che sta acquisendo, come devo fare? Che io non lo conosco qui. Per quello, grazie mille, scusami caro. Ciao.
Want to try your PC, your show? Okay, what you have, PC or Mac? Mac. Oh, Mac. Okay. Now we just take just a few minutes because we need our technician. If you want to prepare your Mac. Thunderbolt suo?
Arriva verde.
Si arrangiano? Ok. Please. Just a moment. Before you switch on. Oh, here we see. Let's put this one. Okay.
Okay.
Here we are. Okay. Lo freghi prima che la accendi.
Solo che ho preso il 2024. Lì come gli arriva? Che anche lì
The
da
secret is to make sure to put into the cable before you switch on your PC, your Mac.
Okay.
This is a secret.
Also the
Switch off.
switch off on the.
Okay, if you want, we can try, but this is not the correct. No. Please.
Okay, thanks.
Ok? Abbiamo provato anche da acceso. No, si prova prima così, bisogna anche vedere se lui ha HDCP disabilitato sulla come si fa? Se no c'è l'impostazione della scheda video che serve ad ascoltare HDCP e attivare HDCP, visto che è tutto digitale e così si vedono tutti i device digitali.
So thank you for coming to my presentation, and I talk about how to apply deep learning to 3D objects. So this presentation consists about two parts. The first part, you will get knowledge about how to approach making the deep learning product. The second part, you will get knowledge about deep learning applied to 3D objects. So the first part consists about these things and strategy. Find the right problem, find the right method, and keep re-challenging and focus. The second part is deep learning applied to 3D objects. I will talk about the BoxNet and how to improve it to BoxNet and the results. This is my self-introduction. My name is Masai Oguchi. I work at Kabook Inc. and I'm an image processing developer. This is my Twitter account. What is a Kabook Inc? Kabook Inc provided the on-demand manufacturing service. Sometimes receives the 3D data to manufacture by using 3D printers and others. So that's the reason why I talk about deep learning applied to 3D objects. So the first part is strategy. Find the right problem. Would you like to use deep learning to solve your problem? Is anyone? No? Oh, thanks. So what is the best case to use deep learning? So the most case, image processing and speech recognition are high performance than the other method. In some cases, it is possible to apply the natural language processing and time series analysis. What is the worst case to use deep learning? So not enough data, cannot prepare a pre-trained model and need 100% accuracy, because in general speaking, machine learning is impossible to achieve the 100% accuracy. So the next is find the right method. How can you find the best way to solve your problem using deep learning? In the most case, use let's go search Google it. Not possible, because if you use Google, you have to know about the good keywords. So at the first time, you don't know about the good keywords. In my approach is using Google Scholar. So it is get the following things: good methods, good keywords, which university laboratories know about this problem. So you already know which university laboratory site is good, so it is possible to get the code and data. So in my case, Princeton University provided the data and code. And GitSib is provided the GitHub and the latest paper, so you will get the code and paper. And following Twitter user, so it is possible to get the latest information. And then, so the book, you will get the structure, knowledge, and active. It is provided the paper site, so that you can find the latest method. And so you already know the good keywords, so that you will use the GitHub and Google. It is possible to get the good code and good knowledge. So the next content is keep re-challenging. So you gather a lot of training data, so let's start using the full data set. Not possible, because a lot of training data, it takes a lot of time to train, so you have to check the first thing. First thing, prepare a small data set and check module works correctly. And second step, prepare easy to verify training data set. Most models can be trained with data sets such as MNIST. You have to check it works. And deep learning no official method to improve accuracy. So you have to check the training accuracy and validation accuracy. If both accuracy are not improved, so you have to stop it. And check the result by the visual board such as the TensorBoard. And you have to increase in challenge times by improving the calculation speed using GPU, optimized CPU. Focus. Deep learning are a lot of methods to improve accuracy. So the model, how deep, how is it structured, adjusting the hyperparameter, and pre-process data, data augmentation if you're using graphical data, and optimizer, SGD, alarm, and so on. So depending on your situation, so the enough computation resources and enough data to a deep and complex model. So enough computation resource, but enough data, find a good pre-trained model and focus on the pre-process such as data augmentation. So not enough computation resources or data, consider other ways to solve your problem such as logistic regression, SVM, random forest. Deep learning probability isn't best choice. So the end of the first part, I will talk about the next part, deep learning applied to 3D objects. I will talk about BoxNet. There are a lot of deep learning models. How to choose one? I consider three things: resource, performance, speed. So resource is the computation resources and human resources. Performance is accuracy, and speed of development. I choose the BoxNet. Why choose the BoxNet? So BoxNet advantage the resource and speed. So computation resource is good because in my environment it works. Memory 32 gigabyte and GPU type is there, and performance is accuracy so 83% accuracy in the paper, and speed is open source and simple core. So I will talk about BoxNet processes. At first time, so the maps 3D data to 32 voxel. So the 32 it is possible to choose it and reduce data size because 3D data is a rich data, so we have to reduce the size. And the input is a convolution 3D. So the convolution 3D is effective for the filter. I will explain about the 2D cases. So because the 3D case is difficult, so prepare the input image and prepare the kernel window. So we will watch the red spaces, and input image value is 1 and multiplied 5 and plus, and input image value is 1 and multiply 1 and plus, and repeat the action again, and it is get the value convolution feature is 33, and the repeated action orange spaces, green spaces, blue spaces, and it is get the convolution feature value. And then so talk about the 3D cases. I will provide it the input image and the 3D kernel. And 3D kernel move to the image and all image map and provide it convolution feature. And then move the inner and provide it the convolution feature. Repeat it action again. So they get the first convolution feature layer. So in figure cases, repeat 7 times action. So if you're interested in the implement of the code, so if you use the keras, it is only one liner. So in this case, 32. So in that case, the input shape is 32, 32, 32. In the last one meaning about the color channel, and the setting of the kernel size, and the slide is how the kernel move it, and data format meaning about the which color channel. So the keras support for the TensorFlow and Cyano. So the TensorFlow and Cyano are different input shape. So that's the reason why the setting the color color channel. So the next step is the max pool. So max pool effective for the detected image, and then so it gets the composition feature layer and selected the max value. In that case, red spaces max value is 6, so the get 6, and the orange spaces get the max value 8. Repeat the same action. The max pairing action for the 3D data is the same action, so the provided to the pooling window and the convolution feature. Repeated action. Get the max pool layer. And if you use the keras, it is only the one-liner, so the setting size and the channel. So the input image, so the filtering and detect and the fully connected and limited sizes because of the in the classify cases, number of class and apply the softmax function. A softmax function, it maps output probability distribution and it is easy to differentiate. So the keras using only these things, so the define about fully connected, limited size, limited number of class size, and softmax layer. This code is defines the model. At first, it defines the model and the convolution 3D, and the max pool, and fully connected, limited size, and applied softmax function. So it also defines about the loss function and the metrics, and then training the data, so the setting the voxel mapping data and setting the classify level. So I will talk about the next step is the improving technique, accuracy. I think improving accuracy has two approaches. The first approach is the model and the second approach is data. So model approach a variety of ways to improve accuracy. Disadvantage, deep model takes a lot of resources and it is obvious which model is better. And data approach advantage is the effect of change obvious and disadvantage approach are limited. So in my case, model approach is applied to random dropout, leaky layer, and data approach is data augmentation for 3D data and class weight for unbalanced category data. So 3D data augmentation is a specialty case, so I will talk detail about it. I think data augmentation has advantage over the other method. The effects are obvious and it does not increase in calculation time unlike adding layer to the model. So data augmentation, these things, so the changing data, rotation, shift, share. So if you apply to the code, so they provided the voxel data and each voxel data applied to the augmentation matrix and getting the changing data and rechanging the NumPy format. So I will talk about the example case, rotation matrix, this one. So the changing data is a rotation. Shift matrix, changing the data, this one. And share matrix, changing the data, this one. So in my case, so adding the data augmentation data for the training data. So improving technique speed. Deep learning has a lot of ways to improving calculation speed, such as use GPU or CPU optimization, multi-thread, prepare feature set. So the CPU optimization very effective for the data augmentation. So I will talk about CPU optimization. So if we use the TensorFlow, so setting the build option, it is possible to apply the CPU optimize. However, you have to check which option is available. So the result. This result shows the validation accuracy. So the blue line meaning the baseline, and the red line meaning about the data augmentation, shift X and shift Y. And the yellow line meaning about the shift X, Y, and apply to class weight. And the green line meaning about adding the training data by the data augmentation and apply the class weight. This table shows about these results. So this is the result validation accuracy. So the baseline is 79%. However, so the adding the shift X and Y data and apply the class weight achieves 85%. So the conclusion. So at first part, my strategy find the right method and find the right problem and find the right method and re-challenge and focus. So the other case, so the right problem is 3D object recognition, and the right method, I choose the boxnet, and re-challenging data augmentation and customized model, and focus improving the validation accuracy. I will show the demo. This site show about the similar 3D objects. However, so this text is Japanese. Just a moment. Sorry, it takes a lot of time. I prepare the video. Okay, I'll show the demo. Choose the file about the airplane and set it. Okay, sorry. あれ So upload it the airplane. It is possible to find such as similar shapes. And the next content is a bathtub. So the last content is a toilet. Toilet and chair, it is possible to find. Search it. So the end of the presentation and shows the recruiting. I think deep learning for 3D object it is very rare case. And if you're interested in the working in Japan, so you have to access the site and send the email. That's all. Thank you for listening my presentation.
Okay, so we have about 5 minutes or so for questions, if anyone has any questions.
Hello, thank you for your presentation. And do you have any other metrics or just accuracy? Because accuracy, especially if you have imbalanced classes, could be pretty misleading, like any kind of loss or precision recall. What about them?
So your question meaning about the other calculation matrix, so such as rotation and so on?
Basically, because you said you had 80%
Uh-huh.
accuracy.
Uh-huh.
And for example, what about precision and recall and other metrics?
Other metrics? Sorry, so I only calculate about the accuracy, so not calculate it as a metrics.
Okay, thank you.
Any other questions? Okay, well, thanks again for the talk. Thanks for your patience there. Since it's a break after and we're about 10 minutes late, we might go over ever so slightly, but we'll try not to keep you from the coffee. Otherwise, please give Rashad a warm welcome as he talks to us about optimization using flow networks.
Hello everyone, my name is Rishabh Dal and I am a student at IIT Varanasi. The topic of today's talk is optimization using flow networks. The talk can be seen as in three parts. In the first part, we will have pretty basic introduction to Network X library. It's a library we use for dealing with graphs. In the second part, we will discuss a thing about what are the flow networks, what is the maximum flow, what is the minimum cut. These things are mathematical concepts, but we will see how we can use these concepts for dealing with some optimization problems. Flow networks are generally used for getting optimized solution for something, and these days they are also used for approximate solution like in emergency evacuation planning and all that. So, and in the third part, we will discuss a problem called project selection problem. And we will discuss how we can model the problem into a flow network and prove that the minimum cut of this problem gives us the solution, and within 5 to 6 lines of code I will solve the problem in Network X. So we'll start. It's not displaying it on that.
Okay, I think you need to, because it's not mirrored. Do you need mirrored? And then I guess we might need to change back.
Yeah. So in Network X, we have 4 types of graphs. First is the simple graph, undirected graph which do not have any parallel edges. Another is directed graph which have parallel edges, and then undirected graph with parallel edges, and similarly directed graph with parallel edges. So first of all, it's a pretty basic functions like add node. Node can be an integer, and then there are some, we can add some attributes to the node too, like color, weight. These are used for various algorithms. And one good thing is the node do not need to be integer. It can be any hashable object, like it can be a string, it can be a mathematical function, or even it can be a graph itself. Like I have added the graph itself as a vertex into the graph. And some pretty basic function like g.nodes gives us the nodes. We can iterate over the nodes, all the nodes are here. And for adding edges, there is add edge A to B. A to B were not originally added as a vertex in the graph, but it will automatically add them as a vertex in the graph. And weight, some colors and all that. For accessing the edge, you can access them just like you access a multi-dimensional array. So G25 and G52 are the same thing because we are dealing with undirected graphs. And we can add the edges from a list as well. Similarly, we can add nodes from a list as well. And some pretty basic function like number of edges, number of nodes, number of self loops. Network X a lot of these functions which comes very handy while writing small script when you are dealing with graphs. And this is the thing I like the most, like you can draw the graph pretty easily. It comes very handy when you are dealing with very large graphs, you are trying to find some relationship between the population and all that, and it can be customized very easily. You can change the edge length, edge color, and everything like that. So till now, the nodes were not integers, like the one node was a mathematical function sign, one node was the graph itself, one node was string, somewhat integers. So you can just convert them to integers if you want and keep the old labels too. So like here, the old node that was a mathematical function sign is now number 5. So the graph remains the same, just the labeling is changed. It's pretty easy to iterate over the edges, print the information and something like that. And these are some algorithms that, these are just 1, 2, 3 algorithms that I'm discussing. There are a lot of, almost all the graph algorithms are available with Network X. Like the connected components is the set of vertices that are connected to each other, means we can reach to each other just by going over the edges. So here 0, 1, 2 and 7, 8 are in different connected components. So if I connect 0, 7, they will be in the same connected component. You can relabel the node to create a new graph, and you can take union, intersection of the graphs. The shortest path gives the shortest distance using the Dijkstra algorithm. Shortest path here between 10 and 12 gives an error because the 10 and 12 do not have any path between them. Then shortest path between 0 and 8 is 0, 7, 8. And then is dominating set. Like if you know about the dominating set, I'm just showing you the simple algorithms. So this was just a simple introduction, like how to create a graph, add a node, add an edge in the network X. Now we will see something about the flows and the cuts in the graph. So first of all, let's just see about the history of the network flows. So around in 1955, some US Air Force researcher published a classified research in which they studied the 40 regions of Soviet Union. The Soviet Union was connected to satellite Eastern European countries with railway networks. So they studied 40 of the regions, 105 edges. So edges are just the railway network between two regions. So they were studying it, and they gave a weight to each edge, and the weight was how much material you can pass from one region to another. What their intention was, just like these cats, they wanted to bomb the railway networks. They wanted to disconnect the Soviet Union with its European countries, and there was a cost related with bombing each railway network. So they found a set of edges such that bombing them was cheapest, and it was cheapest to disconnect the Soviet Union from its European countries, and they were successful. So let's see what did they used. So what's a flow network? Flow network is a directed graph which generally do not have parallel edges, and we have two very distinct nodes in it. One is the source and another is the sink. Source is from where the flow starts, and sink is where the flow ends. And for each edge in the flow network, each have a capacity attached to it. Like the capacity is the maximum amount of material that you can flow through that edge. So this is an example of flow network. Like S is the source, T is the sink, and given are the capacities of all the edges. Like capacity of the edge S to 4 is 15. It means you can pass 15 unit of material through edge S to 4. So, sorry, it is supposed to be this way. I have changed. So the flow from source S to sink T is a function which satisfies two assumptions. Like the flow on any edge is greater than 0, obviously, and it should be less than the capacity of that edge. And for every vertex that is not the source and the sink, we have a conservation of flow. Like for every vertex other than source and sink, the flow that is coming is equal to the flow that is going out of the vertex. And the total flow is how much we are getting at the sink. Like this is an example of flow. So here we are pushing 4 units of material from source S to 2, then from 2 to 3, 3 to 6, and 6 to 4. This is a valid flow because we are not breaking any of the assumption. The flow is less than the capacity in every time, and all the vertex have the conservation of the flow. So this is the maximum flow that we can get from this flow network. So we are pushing a flow value of 28 from the source, getting it at the sink, and all the edges are satisfying the assumption, like the flow in them is less than the capacity of the flow, and for each vertex the conservation of flow is working. We cannot pass more than 28 units of flow through this network. Just remember the number if you can. So this is the maximum flow, and now we jump to the cuts of graph. So till now we discussed what is the maximum flow in a graph. Now we will discuss what is the cut of a graph. So in cut of a graph, we try to partition the graph into two subsets, A and B. Generally, we say that source belongs to A and sink belongs to B. The idea here is to cut some edges such that the maximum flow from source S to sink T becomes 0. Just like the air force researchers wanted, they do not wanted any material to flow from the Soviet Union to the Eastern European countries. So they just wanted to cut some railway networks in between. The capacity of the partition is calculated as the sum of the capacities of the edges that are going from set A to the set B. We are not considering the edges that are going from set B to set A because they will not participate in the flow. So the capacity of the cut is the capacity of the edges that we cut that are going from set A to set B. The pretty simple cut of the graph will be to disconnect the source from the graph. Like here, we are just disconnecting the source from the graph. So we are cutting all the three edges that are connected to the source, which have capacity 10, 5, and 15. So the capacity of this cut is 30, but this is not the optimal case. Like we want to find the minimum cut. This is the trivial case, like we can always separate the source from the network. So we want to find the minimum cut, and this is the minimum cut. Like if we destroy the edge from S to 2, 3 to 6, and 7 to T, the sink, then the capacity of the cut will be 10 plus 8 plus 10, which is 28, and the max flow was also 28. So this is another theory that some guys from the Soviet Union also studied the same network at different time. They wanted the good thing. They were calculating how much material they can actually pass from the Soviet Union to European countries, and the Air Force researcher wanted to cut the network. So they actually found the same number if you give them the same weight. So in every network flow, the max flow is always equal to the minimum cut. So there's a guy called Fulkerson who gave this theorem that in any network, the value of the max flow is always equal to the minimum cut. Like here, all the flows and the cut of the graph are shown on the same flow network. So you can see the sum of the capacities of the cut and the flows are same and is equal to 28. So what are the application of network flow? Network flows are used in network connectivity, bipart matching. Airline use them to find the minimum number of planes they need to serve all their flights. It's used in image segmentation to separate the background or foreground of an image. It's used in project selection, which we will discuss. It is used in baseball elimination, like they eliminate the teams which do not have any chance of going further. Now we go to the project selection problem. There will be a little bit of mathematics involved. So you have a company which need to carry out some projects. And let's say you have a set of projects P. And with every project is associated a value, the revenue of the project. So if the PI is greater than 0, then the project is a profitable project, like you are gaining some new clients. And if PI is smaller than 0, then it is a losing project, like you need to hire some new guys. And just like in real life scenario, the projects are interdependent. You need to do some project before doing another. So some projects are prerequisite of another projects. So we are given with a graph G, where an edge from A to B shows that you need to complete the project B before doing project A. So now we need to find a subset of project which gives us the maximum profit. Like a subset of the project which is complete in itself, like we are doing all the prerequisites of the project that we are involved, and the profit is maximum. So just like this cat, we are looking for the maximum profit and the projects we need to do. So how we will reduce the problem to network flow? So first of all, the problem we discussed right now, that there is a set of projects we want to do, there is no potential source and sink in this problem. So first of all, we will make a source and a sink for the problem. And now we need to add more edges, more conditions between the projects. So for every project that have a positive revenue, we will add an edge between source and the project with the capacity of the revenue of the project. And for every project that have a negative revenue, we will add an edge from the project to the sink with negative revenue. Like the project, we are doing it for the projects with negative revenue, so it means the capacity of the edge remains positive. And and the edges that were given us in the graph, like the edges that represented the relations between the projects are prerequisite of one another, we will set the capacity of these edges to a really high number, because while we are finding the cut set of the network, we do not want to cut those edges, because if we cut those edges, we will not get a feasible feasible set of projects. If we are cutting a prerequisite edge, it means we are missing some prerequisite for some project that we are taking. So we will make the capacity of these edges to be a really high number so that they are not included in the cut set. So if you make it to the equal to the sum of positive revenues, it will be fine. So now we have represented the graph into a network flow. We have three types of edges. One is going from the source to the projects which have positive revenue. The other type of edges are the interrelated edges, like some projects are prerequisite of another project. And the third type of edges are edges going from the project with negative revenue to the sink. So now let's see what will be the cut value of this graph. So this is a bit of mathematics. So we have three types of edges in our graph, and we will not be cutting the prerequisite edges because they have really high capacity. So we will be cutting two types of edges, one that is going from the source to the project, and second which is going from the project to the sink. So when we are cutting a edge which is going from source to the project, the value it contributes to the cut is the second term in the first line. And then if we are including a project with negative revenue due to the prerequisite need, then we are cutting from the sink side, so it will be contributing the first term of the cut. So if we can expand the second term, like the summation of pi when I does not belong to set A, we can expand it to summation of pi when I belong to the whole project, subtracted summation of pi when I belonging to A, the subset. So it will reduce to this, the summation of pi when I belonging to complete set P minus profit of A. So because this is the profit of A, like if I take the summation of all the PIs in our subset A, that is the profit we are getting from A. So the cut value is reduced to summation of Pi for which Pi is greater than 0 and I belonging to our set P minus profit of A. Now since the first term is a constant term for a given set of projects, we see the cut of graph is a constant minus profit of A. So if we minimize the cut, we will be maximizing our profit. So for now we have proved that the minimum cut of the graph gives us the set of projects that have the maximum revenue. Now we will just go for an example. Like there are some projects which some have positive revenue, some have negative revenue, and there is interdependence between these projects. Now we need to select projects which have the highest revenue, and that is a feasible set. So I guess it's not possible to do it by hand or mind, by just saying it. So we will just represent the whole graph in network X and use the minimum cut function of network X to find a solution. So For the network flow, we will be creating a directed graph, the line 44, I cannot point it. So line 44, we will be creating a directed graph, and the image I've shown here, I'm adding the edges manually. I mean, if you will be using networks with some script, you will not be adding the edges manually. So I have added the edges, the pairwise, all the edges, and we needed to set the capacity of these edges to be a really high number, and NetworkX do it by default. Like, I have not mentioned the capacity of these edges, so it will consider that the capacity of these edges is infinite. So in line 46, I have calculated the sum of all the pi that are greater than 0 and that are present in a set like p. So that is the constant that we found in the formula we derived. And so if we found the minimum cut, nx dot minimum cut from source to sink, we see the value of the cut is 21, and we get two sets, 4 at 10, 11, 12, 14, minus 13, minus 3 with the source. So the set with the source is the set we should choose. It is the feasible set which have the maximum profit. And if we subtract it, subtract the total if we subtract the minimum cut from the constant C, we will get our revenue. Like 43 is the total revenue you can get while choosing projects from this graph. Like, if you choose all the projects on the left side of -1, we are good to go. Okay, that's the end of slides. Any questions? Yeah, at the end of talk, any questions?
Thank you. Okay, yeah, so we have time for a few questions if anyone has any. Okay, well, thanks again. We can continue in the coffee break, and do remember to vote, rate talks in the app. Thank you. Maybe do a higher resolution.
I tried, but the graphics card then.
720p, then there's an online. It's an old laptop, maybe. I don't know if it's okay, great. That's fine. Thanks.
Hello. Is it? Hello, I'm Stephanie. Hi, nice to meet you. Is the screen on? HDMI.
No. Then what kind of question you got? Sorry, hold on a second.
No problem.
Speakers in this session is Stephanie Mifsud. Stephanie is working for Hotjar, a web analytics company based in Malta. And I had the opportunity to speak to someone from the company yesterday, as this is one of our sponsors, and I was very, very impressed by their job advertisement. So even if you're not looking for a job, this is worth taking a look at. And no, they are not paying me for saying this. So the title of Stephanie's talk is Optimizing Queries for Not So Big Data in Postgres. Please give her a big hand.
Hello everyone, I'm Stephanie and I'm a full stack developer at Hotjar. And as was already explained, Hotjar is an all-in-one tool for user analytics and feedback. So we get loads of user data. But is it really big data? So how big is big data? So at Hotjar we have above 400 million recordings. We have 4.5 billion records in a single table. And our recordings come in the thousands per minute. And we have an overall request rate of 750,000 requests per minute as well. But is this really big data? So what defines big data is basically that we start outgrowing the normal relational tools and we need to go into a new set of tools which are more suited for bigger data, basically. So at Hotjar, we're basically nearing this limit. Sometimes we play a few games with Postgres as well because we're nearing the limit of either storage or performance for certain tables. So this talk today is about the good decisions we made with storing our data in Postgres, and I would like to share these with you, and also the things we had to figure out in production, which were quite surprising and adventurous at times, and basically the tools we used to handle these situations. So we're going on a journey together, and we're going to imagine that we're going to start building our database from scratch, as though we have nothing. And I will first go through the good decisions, which we made, and then I will also explain the tooling, which will help us when we deploy live. Ready? Okay, let's go. So the first thing we need to consider is normalization. So textbook data normalization is a three-step process by which we eliminate fields from a table which are not directly dependent on the primary key. However, in real life, we need to achieve a balance between the consistency of the data in our data store and also its performance. So we need to make decisions in a way which makes sense, basically. So Postgres offers us the best of both worlds because we can have schema-less data inside the JSON schema field, and we can also have relational tables. Now, what makes us choose one or the other is basically the data itself. So at Hotjar, we have data relating to our users, our subscriptions, our accounts, and in this case, it's very important that the data remains consistent. So we use the referential constraints of the database, and we have very normalized tables over there. However, when we come and gather user data from surveys or polls, this is a little bit more dynamic, and it's not so well defined. So in that case, we can afford to put it in a JSON field, and maybe do the validation at a model level using, at the API level using JSON schema or using Marshmallow schema. This will give us kind of the best of both worlds because the storage doesn't need to verify the contents every time. Okay, so now that we're happy with more or less how it's going to work, the product owner needs to make a few changes. So where are we going to add this new field? Though it's very nice to know beforehand how the product is planned to evolve so we can plan future changes, it's not always possible. So the idea is that as the product evolves, we need to keep our models healthy to be able to achieve code maintainability and readability, and to understand the journey of our models, because our database might still hold data from previous definitions. So the way we do this at Hotjar is by versioning our models. So both when they are in normalized tables, we can add a version column, and when they are nested inside JSON fields, we can also add a version field inside the JSON. So now this gives us basically, we have new fields, but we can also identify the behavior of the different types of versions of our data at the API layer. Okay? So, what's next? Now we are ready to use our tables from the code, because we're pretty well defined with what we want to do. So should we use ORMs? ORMs give us a few benefits, some of which are that we think at a higher level of abstraction. So we don't need to think about this table being joined with this table, but we think at a higher level more about the business logic and how to make that readable in code. So, and ORMs also give us same defaults for table creation. ORMs and frameworks are also a very nice benefit, because some frameworks are very tightly knit to ORMs. For example, if we speak about the Django admin interface, it's very heavily based on the Django ORM, and it gives us nice goodies for free, so that we can basically view the data from an admin interface without having to write all the creation, updating, and deleting code. Okay, when it comes to handling transactions in a web application, there's, for example, Flask SQL Alchemy, which will manage the transactions for us within a web request and ensure that they're committed at the end. Again, this is heavily based on the SQL Alchemy ORM. When we advertise ORMs, there are some cases where there are parts of ORMs which are advertised as benefits, but may not be so. So I want to put a little note here to be careful, because one of the benefits being advertised is that you can switch between different backends. So it's tempting to use Postgres as your production database and SQLite as your test database, for example, because it's allowed within the ORM. However, this may lead to discrepancies, and you might get surprises when you deploy your code to production. So it's best to keep your test environment as close to your production environment as possible. Another one is automatic migrations. Certain ORMs support automatic migrations. However, if you have a high throughput server which is receiving lots of requests, the SQL generated by the ORM for the migration might not be optimal SQL, in the sense that it might cause locks on tables, and this will cause the request time to spike. So you might need to rewrite that SQL to make it more performant, to do parts at a time, to run indexes concurrently. So don't just trust the migration code generated by the ORM, but check a bit what your needs are in this regard. Okay, so when we speak about ORMs, what about performance? ORMs do give us a performance hit. So how do we handle this situation? Should I use stored procedures? Well, at Hotjar, we use both ORMs and stored procedures. Whenever we require a better performance, we drop into stored procedures. However, there are, of course, cons at this. First of all, we spread the business logic from basically a single module to 2 different places. It's deployed half on the database inside the stored procedure and half in the web server in the API. So it makes things less readable. And also stored procedures run within a single transaction. So if you have lots of things going on in them, they might increase your chances of deadlocks. So the good practices are, if you're going to use stored procedures, keep them small and modular, and version them as well. So you'll be, if something goes wrong with the new version of the stored procedure, you'll be able to roll back your code easily and rely on the previous version of the stored procedure. Okay, so I think now we're ready to go live, right? We made some performance considerations and we're happy with our model. So, yep, now that we're running on live, things are different because we cannot predict how our requests are going to use the database. So, once we're running live, we identify that we have slow queries. So how are we going to go about knowing which are these slow queries? I hope for your sake that you have monitoring set up. So in this case, you will be able to see which web requests are not performing as well as you'd like. But this doesn't necessarily point us to the query because the web request might be doing so many things. So in this case, we basically pull out pgstat statement from our toolbox, and this will give us the call frequency and the timing of the currently running queries to be able to help us identify which one is the slow one. So once we know the culprit, what do? Basically, explain analyze buffers is the next tool we would like to use. So when we run explain, what happens is we get back a query plan, which will be used by Postgres to actually give us our results back. When we run explain analyze, we will actually run the query plan and get the exact timing that it's going to take. When we use the buffers part as well, it will tell us how many pages Postgres is reading, basically, to give us the data back. So there are two numbers which are given to us for buffers, and if there is a high hit in the shared pages, it means that at least the results are coming from cache. However, if there is a high number of pages in the red buffers, this means that it's coming from disk. So it is also slower. As a general rule, the number of buffers hit should never be too high, because in that case, you might be going over too much data and you might need to optimize it in certain ways. Other things to look out for are nested loops and full table scans. These might require indexes to basically improve them. And also take a look at how your query is using, how you're basically querying your data. If you're always using two specific fields, you might benefit from using a composite index, by which the index takes both fields into consideration. And if you're doing some computation to a field before querying for it, you might also benefit from having a computed index, which stores the computed value within the index itself. So if you're doing some transformation to the data before in the query, you might consider putting that transformation in the index you create as well. Okay, so now we're a bit smarter with our queries, but what if Postgres is not choosing the optimal plan? So if the query plan is still not performant enough, is it Postgres' fault? Well, let's try educating the query planner, but at this stage I have a big disclaimer to make. He's a very smart guy, so he's usually right. So we need to be careful here. Let me go through a bit how the query planner actually gets his decisions. So when we run analyze on a table, so it's not explain analyze now, it's the analyze you run with vacuum. The query planner statistics get updated. So the query planner will get around 100 rows from your table and base its query plan on these. However, if you have a table in which columns have very irregular data distribution, you might benefit from giving the query planner more statistics to base its decisions on, so that it can come up with a better query plan. So in this case, we can use set stable statistics and basically increase the number of statistics. so that the query planner can take better decisions. But other than that, he's usually right. So now we've done quite a lot of improvement to our query plans. However, some table joins are still very expensive when running web requests. So what can we do about that? Basically, having materialized views and materialized tables can help us in this direction. So materialized views are created by creating a materialized view based on a query. So the result of the query is computed once and stored in this view. And whenever we need to update it, we need to call a refresh to have it updated with fresh data. This makes lots of sense whenever you need to generate reports daily or hourly, because you can take a bit of time to refresh the data. However, when the data needs to be updated continually, it can be expensive to call a refresh on the materialized view, especially if it's a big query. In that case, we can get around this by building our own materialized tables, which are basically tables that we populate at the same time that we populate the normalized tables. So let's give an example. So if I'm entering subscription details, and I need to populate the account table, the customer table, and the subscription table, I would also, in the same transaction, try and input data also into the materialized table, which would combine the data from these three tables, so that when I request it from the materialized table, I don't have to join. And this gives me the performance benefit. Another way of doing this is by having a trigger on one of the normalized tables, which will then populate the materialized table itself. Okay. So we've learned quite a few tricks so far. However, aggregations do deserve a special mention. Would you select count in a web request? Well, if you always know that the results returned are going to be of limited size, it's fine to do it, but usually you might get surprises because people tend to use your APIs in ways which you cannot predict. So it might give you a performance hit in certain queries. So the idea is that though it's hard to cache aggregations, because we always want an updated value, we might not require down to the second updated value. So in this case, we can basically cache the result of the aggregate for 5 minutes and refresh every 5 minutes. At Hotjar, we do this by having web requests selectively update the cache. So the web request would need to take a lock and say, listen, I'm in charge of updating this value now because I can see it's going to expire soon. And then, so that we avoid the cache stampede problem when everyone tries to update an expired value at the same time. Another way to do it is by having a background worker take care of this. So it's not done in the web request itself. Also, at the moment we're speaking about aggregations when we need to read them, but when we're continuously updating counts, by actually incrementing fields inside the database, it also makes sense if our performance allows it. If we can lose like 5 minutes of data and it's not too bad, we might also want to cache that first and sync to the database at regular intervals to avoid creating too many updates in Postgres, because if you create updates at a very high rate, Postgres won't be very happy. Okay, so there's something still lurking in our database which might cause us trouble intermittently, which is a bit worse now. So welcome to deadlocks. So I explained deadlocks in this way. Imagine you have 2 kids and they each have a toy. And of course, each wants the other kid's toy without giving up its own. And this is what happens when we have a deadlock. There are 2 transactions going on, and each has a resource which is required by the other transaction, but neither of them want to let go of their current resource. So in the case of the kids, you would have a parent or a carer come and take one of the toys and give it to the loudest kid. In the case of deadlocks, Postgres does this mediator job, and one of the queries will fail, and one of your users will get a failed request. Due to the nature of deadlocks, since they're not very predictable, repeating the request will probably make it work, so it's not too bad for your end user. However, the symptoms are that queries slow down when we have deadlocks. So, and if the throughput really increases, it can really bog things down. So we need to take care of them. Okay, one of the ways to take care of this is ensuring that we're using a recent Postgres version, because sometimes they give out updates which can prevent certain classes of deadlocks, but mostly we need to take care a bit about how we write our code. So over here, you probably can't see this query, but I'll make the slides available later, and this is a very useful query for identifying deadlocks. And it uses the pgstat activity view and the pglocks within the query. So these are two tools provided to us by Postgres to help us identify which transactions are using which logs, and if we see that they're being held for too long, we can possibly identify that there's a problem. Okay? So, at this stage, we need to speak about table and index bloat. So this, I mentioned before that Postgres isn't too happy with updates. So what happens when we have table and index bloat, specifically table bloat, is that when searching for results, Postgres has to jump over a lot of rows which have been deleted or updated, but their space has not been returned to Postgres yet. So basically, index bloat happens due to how Postgres manages transactions internally, and basically can be fixed by running a vacuum full. However, running a vacuum full will hold an exclusive lock on the table, so it might not be advisable to do this in production environments. So there are a number of extensions which can be used to improve the situation and remove the number of dead rows and basically give the free space back to Postgres. So one of the symptoms of having table bloat is that the storage space in your database goes down really fast, faster than you would expect, than the rate of data coming into your database. So just a quick run through. pgsqueeze is something you set up once, and it takes care of bloat continually, because you configure the level at which the bloat needs to be controlled. pgcompact is advised for toast tables, which are basically tables which have blobs inside them and will refer their storage to other tables under the hood. And however, it needs to be run specifically with a parameter which specifies the number of pages it's going to clean up. And pgrepack can just be run once whenever the need arises, basically. Okay? And we use pgstat tuples to actually identify whether we have index or table bloat. So we have put quite a few problems under the carpet by my asking you to shove them into a background worker. So let's speak a bit at the end on how to keep these background workers healthy. So ideally, background workers pick their jobs from a queue, so that if one of the background workers dies, the job can be rescheduled. Also, we should keep the duration of the job predictable and do very little inside the background worker, so that we can distribute also the tasks between multiple servers. So when we do this, there isn't one machine under load for an hour-long task, basically, but we can basically monitor and profile the background workers easily. Another tip is to use server-side cursors, when we're obtaining a large amount of data. This also incurs a performance hit on the database, but it will protect memory within the background worker. So the advice is don't use it in a web request, but basically use it inside the background worker. This is a cheat slide because it's not about Postgres, but I've mentioned caching, and caching can be done in 2 different ways. We can either cache small tables within the web request, within the web application, but we need to be careful with memory in this case, or else we can use session store caching stores like Redis or Memcached to keep our cache data for us. Last thing I want to mention is how to handle deletes. We haven't spoken about deletes at all, and when one day we realize that our database is getting full, and we say, listen, we have loads of data which we haven't used in ages, and can we delete that? First of all, deleting it all at once will not make Postgres too happy. And second of all, your users might not be informed that this data might be removed. So planning a data retention policy upfront will help in this regard, that you, as soon as the data is not covered by the retention policy, if it's 1 day older, you can start deleting data which is at least 1 day old. And in that way, you balance the deletions by doing them daily instead of by having to do them all at once. Okay, that was all from my end. I'm not sure we have a little time for questions, but if not, feel free to drop by to the booth. There are 4 devs from Hotjar here, and we're mostly there at breaks because there are many interesting sessions we want to attend as well, but feel free to grab us either after this talk or as you see us around here.
And we do have time for questions.
One at the back.
Hi, thank you for the interesting talk. Your abstract mentions sharding in PostgreSQL. I was wondering, what's your experience with that?
Yep. Okay, I left that out because of time, but I can speak a bit about that as well. When we came to basically think about how to expand our Postgres installation, one of the decisions we could have done is basically sharding, because since our data is basically organized by site, so all our features are organized, so heat maps are specific to one site, recordings are specific to one site. So our site ID is a very good thing to shard by, basically. However, when we actually came to do the migration, we ran into performance problems because the transferring of the data and the changing of the format of the data required was basically too much for our current Postgres installation because we needed to do some changes. So the tip is, if your data is suited to sharding, you need to think about it early, even though, because the migration will bite you, basically.
I wish you told me this a couple of years ago.
Yeah, sorry.
You've mentioned using JSON structures in Postgres.
Mm-hmm.
Are you using them like a lot, and haven't you seen any like problems with performance? Or to put it another way, did you have like a need to use something more oriented or on schema-less stuff, like for example Mongo, or can you just disregard Mongo and use Postgres with like schema-less data with JSON structures?
Mm-hmm. Postgres has been suiting us fine, so from a performance perspective, it's not a problem. However, I also need to say that we don't query the nested structures too much. So what the JSON we're interested in is requested by the API as the entire field. We don't search by stuff which is within. So the answer I'm giving you is within this context. However, if you have a look at benchmarks, you see that Postgres and Mongo are both very performant in this regard. So, no, we did not have the need to use Mongo for this.
Okay, thank you.
We have time for 2 more questions.
Hello?
I think it works now. Thank you for the talk. So beyond sharding, which you said it's very hard to do after the data grows, what are the tips you may have while your data is growing, while your products get more successful and your database gets a hit? I know that's the always saying you should throw in more memory and more space, but what other tips you may have?
First of all, it's a good problem to have. That's what we say internally, to console ourselves whenever we need to stay up, to basically take care of this stuff. Monitor and keep tabs as to what's going on, both in the database and in your web request. And yeah, when you get stuff going a little slower, and when you see things like getting incrementally slower, but just little by little, don't ignore that, because it may grow a bit too much at some point. So you should start profiling early to at least keep tabs on the bottleneck, because the more you know about your bottleneck, the more you are in control as to how to fix it, and it doesn't take you by surprise.
Last question. None? Then let's thank Stephanie once again.
Thank you, guys.
has been intensely debated at the PyData conference in Berlin last week. Time flies. And it's titled Despicable Machines, and I'll say the subtitle in Polish, Dlaczego komputery mogą być dupami? Maciej Grykan.
Thanks so much. Thank you, and awesome effort on the Polish. So yeah, my name is Maciej, and I live in Berlin, but the company I work for, Rainforest, is actually based in San Francisco. Most of our engineers are remote, including me. And at Rainforest, we use AI to make software testing better. But today I wanted to talk to you about ethics. And it's kind of a funny thing. Like, when I was going around the PyData and Python-related conferences last year, it was pretty awesome. There were lots of technical talks, you know, deep learning, visualization methods, all these kind of things. And it was great. But then around June and again in November, you know, some things went down in the world, and I started thinking, okay, I wonder if the things that I do have some kind of ethical implications, and I wonder if people care about that and think about this stuff. And I thought, you know, probably not. It's programming, it's just a thing we do, probably doesn't matter that much in the grand scheme of things. And I bet people find this kind of a boring topic. Turns out I was really, really wrong about both of these things. So if you are attending Python conferences and related ones this year, you've probably noticed the trend. Last week in Berlin, and at this conference, there are more and more people talking about this, putting the work in broader context. There are still lots of very interesting, purely technical talks, but now the community seems to start caring also about, you know, trying to make the world better than we found it. And there's lots of people talking about that and thinking about that, and my aim today is to convince you to also join this conversation, but hopefully that aim is already fulfilled, so let's just reinforce it. And just as a side note, I know it's the sort of almost the end of the fourth day, so I have some gratuitous references to British pop culture in the presentation, and if you spot anything, shout, and you'll get a sweet. I'll try to throw it at you if you're close enough. Okay, so before we dive in, I just want to credit some people who have really inspired me to think about that, and I kind of learned a lot from. The first one is Zeynep Tufekci. She's a researcher really interested in technology, and she thinks really deeply about these things. And I can really recommend her. She's got lots of articles, not only about this topic, but also many things related. She's got a book, and there are online talks that you can see. Cathy O'Neill wrote a book on the topic. It's called Weapons of Mass Destruction. Lots of you probably heard about it already, but you know, it's kind of the Bible of this area. And finally, Catherine, who gave an amazing keynote yesterday morning, you know, member of our own community. And she also gave a talk on pretty much the same topic I'm going to talk about today at PyData Amsterdam a couple of months ago. So I try to talk about things from slightly different perspective, but the areas we cover are kind of similar. So, you know, I do my best, but I can't hope to cover everything as well as they did. And just a note, I think it's also kind of interesting that these are all women with different backgrounds. And I think it also goes to show how important diversity is. And I know that our community cares about it a lot, but there is still work that we need to do. Okay, so does anyone know what that is? There you go. You get a sweet. So this is Deep Thought. It's a computer from Hitchhiker's Guide to the Galaxy. And it was built by super intelligent, multi-dimensional beings who got fed up with existential angst at some point and decided to build a computer to give them the answer to life, universe, and everything. And you know, they built this computer, and then they asked for the answer, and the computer told them to come back in 7 million years. But you know, what is a bit of waiting for such an important answer, so they did. They waited 7 million years, they came back, and then the computer told them that the answer is 42, but it doesn't know what the question is. So, you know, this is just a funny science fiction novel, so what does it have to do with reality? I think there is actually a connection, and one of the reasons that Hitchhiker's Guide to the Galaxy is so funny is that it has some very pointed criticism of our society and the way we think, and I think it brings up some really good points. So, first of all, if your question is rubbish, you will not get a useful answer. And that might seem pretty obvious, but keep that in mind because a little bit later we will come back to that. It's not always obvious to everyone. But also, secondly, let's think about for a second, why did super intelligent, multidimensional beings decide to build a computer to answer this question? Like, why didn't they instead decide to invest in humanities and let a well-funded philosophy department sort this out, right? So, I think one of the reasons it was that is because we think computers are objective. You know, a philosopher has their own personal biases, they have their own points of view, and basically they cannot be trusted. Like, not really, right? They are definitely biased in some human way. Whereas computers are, you know, governed by ones and zeros and algorithms and logic gates and have no morals. So whatever answers they give us are unbiased and objective and therefore true, right? Does everyone agree with that? That the answers that computers give us are always true? Awesome. So either I don't have lots of work to do to convince you, or I'm very good at posing questions in a very suggestive way. Okay, so let's say I was exaggerating a little bit. Computers aren't always giving us the right answers, but when they give us the wrong answer, it's pretty easy to tell. Like, you might have a convolutional neural network that is, you know, classifying images, and it might misclassify an image of a cat as a penguin. So, you know, you look at that and you think, it's an obvious mistake. It's kind of absurd. It's very easy to spot. So you're not really worried about it, right? It will not trip you up in any dangerous way. Do you agree that, you know, you can, when a computer gives you an answer, if it's wrong, you can tell whether it's wrong or not? Okay, at least one of you agree with it, but probably not most. Okay, so no one agrees. Awesome. Okay, so even if you can't always spot mistakes, and I guess I know already what you're going to answer, but do you agree that at least things like racism and sexism are, you know, not computer things, they are human prejudices, and computers don't have them? Right, no one agrees as well. That's great. Sure, but when a computer gives you an answer, you know, the question is whether it can contain biases like this or not. So, you know, I guess no one falls into this trap already, which is awesome. So, do you know who these people are? So, there was an article published last year by ProPublica. It's a publication, and basically they explained how predictive policing algorithms work and how they get things wrong. First of all, when you say predictive policing, a few years ago I thought, you know, it would be a joke. Like, Minority Report style thing was a joke phrase for a long time for me. And when I read about that, I was really kind of shocked, but turns out it's not a joke, it's an actual thing. Both of these people were arrested in Florida in 2014. The person on the left, her name is Brisha, and she was arrested for stealing a kid's bike, sort of cycling on it for a few meters, throwing it away and then running, but she was caught and arrested. The guy on the right, his name is Vernon, he was arrested for shoplifting some stuff that was of similar value to the bike. So they were both arrested more or less at the same time, independently. And when they were arrested, their risk of recidivism, so risk of reoffending, was assessed by a system called Compass. So it's a thing that the police in Florida uses. So they put data about the person into the system, and the system says, this person is high risk of reoffending, this person is low risk, and so on. In this case, Brisha was given high risk of reoffense, and Vernon was given a low risk assessment. Now, the article was published in 2016, so 2 years after all this happened. And by that point, we already knew that the system got it wrong. So after 2 years, Brisha didn't reoffend, while Vernon broke into some warehouse, stole much more valuable things, and is actually in prison. So, the system got it wrong. But, shit happens. We know that computers are not perfect, so sometimes they get things wrong. And let's put aside for now the question whether any kind of algorithmic inaccuracy is acceptable for such an important system, because there are even bigger problems that the journalists found. And namely, there is a racial bias in the system. So people of different races tend to be misclassified at more or less the same rates. However, white people, when they are misclassified, are given too low risk assessments, while black people, when they're misclassified, are given too high risk assessments. So there's racial bias in there, and it's actually impacting people. And there is much more to that. There is the article itself is really interesting. There is a separate blog post detailing the analysis that they did. There are also some rebuttals to it. I really encourage you to look into it. It's a very interesting topic. So let's see how it might happen that a system like this can be biased. Do you know what these are? There's no sweets for that. These are word vectors. So I'm just going to quickly explain it for those of you who don't know. In 2013, there was a paper published by Google on natural language processing, and they introduced this system called word2vec. And the idea is you take some corpus of text, you put it into this model, and it spits out an embedding. And it means that what it spits out is a representation where each word is described by a set of coordinates. So in this case, it's something like 300 coordinates, 300 dimensions, but you can think of it as like a three-dimensional space, and each of your words has a position. And if you imagine a word man and a word king, there is a vector that takes you from one to the other. The cool thing about word2vec is that these vectors, the relationship between words, are meaningful in a way that you can take this vector, and instead of applying it to the word man, you can apply it to the word woman, and instead of getting to king, you'll get to queen. And this is awesome. That allows you to do this kind of vector arithmetic. There's a question. What are your axes? Axes are arbitrary. There are these vectors in high dimensional space. So this is just a conceptual representation in 2 dimensions of this 300-dimensional thing, just to get the idea across that there are relationships between words. I don't know. It's so word2vec is taking a word and putting it in some kind of space that axes don't necessarily have interpretable meaning. It's just modeling relationships. So things close to each other, for example, might be related. Things far from each other might not be related. I don't want to make this about word2vec. We can talk about it afterwards, but it's not the topic of the talk. The point is that this is an awesome technique. It's very widely used. It's extremely useful, and it's been used in many papers, including at NIPS. So NIPS is this premier conference for AI. Basically, any paper with neural in the title is very welcome there. And last year there was a paper that described how word2vec is also biased. So turns out that word2vec is trained on Google News. So it's a huge corpus of data, and there is most people, I assume, writing news are not biased intentionally, but just because of the way our society works right now, there are some biases there. And one of the things they discovered is that if you take the word man again, and you can get to a computer programmer. So there's a relationship, this vector, you can think of it, simplifying, as saying, it takes you from when to like a profession. If you take the same vector, apply it to the word woman, it takes you to homemaker. So, there's clear bias there about which kinds of professions people are expected to have, even though it's not really fair. Question? Absolutely. So it's the problem of the training data. Sure. Right. So the point is that even though your technique might be completely fine, if you're using biased training data, you will get a biased result. And it's not surprising, but it took 3 years after publishing the original Word2Vec paper for this paper detecting the bias to be found. The paper also shows ways of addressing that, and the ways are basically trying to sort of pre-process the training data to remove these kinds of biases. If you've heard of metric distance learning, it's kind of a similar idea to warp the space in a way to satisfy some constraints. Some relationships should be kept, some other relationships should be thrown away. And there are also other things you can do. Some of them, yes! Right, so, if you have some training data that you have gathered yourself, and you know that there are some features in it that are actually biased, but they might be biased due to the way you captured it. And you might explicitly, after thinking through it, you might explicitly want to not use these features for classification. So you might just get rid of these columns and you might be fine. But that's not always the case. It's possible that some other features in your training set encode these features that you just got rid of. So even though you get rid of them, if you think of an example of like data about people, name and where they live and gender and race and so on, let's say you want to get rid of gender and race. If you look at a row describing, giving someone's name and let's say interest or postcode, you have a good chance of figuring these out. And our models are also capable of doing that. In fact, we spend lots of time making sure that our models are capable of building up these hierarchical representations and running with it. So they might still use that to to do the classification event, or you might not want them. And to understand why this is problematic, I just want to share a little story that Zeynep Tufekci also mentioned. So she went to this conference for HR professionals at some point, and apparently there everyone was really excited about the system for taking a huge pile of CVs and matching the best people to the job openings, right? So you don't have to troll through your CVs manually, it will just do this for you. And, that sounds great. If you ever did any hiring, there's a huge pain to read all this stuff and then try to figure out who's a good fit for what. So if we had a system that does it automatically, that would be awesome. Let's put a pin for that, in that for a second. At the same time, I'm aware of at least 2 papers who did that. It's possible to take data about someone from social media and predict, classify how the risk of this person getting depression at some point in the future. One paper used posts from Instagram, the other paper used posts from Twitter, and they were actually able to fairly accurately detect who's likely to get depression sometime soon before the initial initial diagnosis. So, it's kind of cool that it's possible, and I'm sure it can be used for good, but it's also a little bit scary. And I'm sure you can now put the 2 and 2 together. Imagine that the system that you built for, matching people to jobs is based on training data. You have people that work for you already, you know who are high performers, who are low performers, and you can sort of extract their features and try to train your system on that. There's no reason why you shouldn't use publicly available social media data. The scary thing is that the system might learn to discriminate on things that you really don't want to discriminate on, like likelihood of depression or likelihood of being pregnant and things like this, that you are explicitly trying not to discriminate against. It might still be encoded into data, and you might not even know about that. And this is kind of a tricky problem to defend against. I think the best tool I know is, I think Catherine mentioned it in her PyDate Amsterdam talk as well, is this legal term used in the US. It's called disparate impact, and there's a precise definition of that in the formula, and it kind of treats your model as a black box, and you can figure out whether your black box is biased or not by tweaking the parameters, seeing what comes out. The thing is that it takes a bunch of effort. You need to be conscious of the fact that this is possible and actively try to investigate it. But I hope I can convince you that this is an effort well spent. The other idea is that some errors can be very unintuitive. So like I mentioned, you know, a cat being misclassified as a penguin, that's kind of, you know, we can kind of understand it. There is, again, at NIPS, but this year, in December, there will be a competition run for the first time about adversarial examples. And the aim is to, you know, you have a classifier, and your aim is to construct a data sample that looks fine to humans, but will get deliberately misclassified by your model. So, you know, you can add some specially constructed noise to your cat image to get it classified in a specific way. At the same time, the other teams will be trying to build models that are robust to this kind of thing. And I think it will be a very interesting thing to watch. But there's another even more scary problem, perhaps, that there are things that no one really intends to happen, but they happen anyway, because some models, when they're not interpretable, and a lot of them are not, make mistakes in ways that we can't really comprehend as humans very well. Now, there was a talk earlier today, it was really awesome, about interpretable models, and there is lots of research going into that area. I think, you know, things will probably get better from that perspective, but it's still not perfect. And I just wanted to sort of point this out, because it's something to keep in mind, that the errors that AI tends to make are often very different from the kinds of errors that humans can make. Monty Python, that's right. So, the idea of stupid questions, I promised to come back to that. Did you ever see a paper where this image comes from? Okay, so just a disclaimer, this paper was not peer-reviewed, it was just published on arXiv, so, you know, don't take too much out of it, but it made lots of waves, it was even covered in mainstream media, and I think it's important to talk about it. In this paper, they had a data set of facial images, and for each one, they had labels saying, this person is a criminal, this person is not. Guess what they tried to do? Take a face and predict whether someone is a criminal or not. And, you know, technically it's not really interesting. They just took AlexNet, if you know about CNNs, and kind of retrained it a little bit and got a very good accuracy. And, you know, after the paper was published, lots of people were outraged, and rightly so. There are sort of many obvious problems with that, but let's just think about some, like the row at the bottom is labeled as non-criminals, the row at the top is criminals. Like, do non-criminals smile? Like, are people with white-collared shirts never criminals? I think that's a little questionable. So, you know, again, silly example in some ways, but that's also something important to keep in mind. Make sure that the question you're asking actually makes sense. Finally, this one is a little bit more obscure. That's right. So it's from the show Little Britain, and this is Carol. She's a receptionist, and she often helps people that try to get admitted to hospital or, you know, get a bank loan. And her trick is like, computer says no, and like to everything. But I think it also illustrates the points. You know, we started off developing these helpers, including machine learning, but not only, to make our jobs easier, to make us more efficient at making decisions and so on. But now, turns out, a lot of time we just defer our decisions to the computer. And when the computer says no, we just are not allowed to do it or are unable to do that. And this is, again, something to just think about and keep in mind whenever you are developing something that might be able to help you. Just consider the implications and what happens when the system gets it wrong. I also really liked the quote, again, in Catherine's keynote yesterday. There was something about a guy who helped develop a system for a bank to write checks. You know, he was wondering if it was an ethical thing to do, because if they didn't do it, then the bank would have to innovate in a sort of organizational way, but they had this new technical thing and they could just preserve the status quo. And I think lots of that is happening right now as well with AI. There are millions of decisions that need to be taken every second. We're incapable of doing that as humans, so we just give it to the machines. But maybe that's not always the right thing to do. So basically what I would like you to do is, first of all, read up on this topic. You already seem well aware of, you know, that this is a problem. Start thinking about it and talking about it with your coworkers and friends. There are lots of meetups and conferences, and I encourage you to really take this seriously. I think it can be really awesome if we do this right, but it can be kind of catastrophic if we don't. So the answer to why computers can be assholes is because we make them. So please don't. Thank you. Question?
Do we have time for questions?
Okay, so thank you very much for your talk. It's kind of like enlightening. What I wanted to ask you is like maybe you should turn the question around. Like you're saying the data that we're putting into our models is biased and we need to kind of like prevent our models from this biased data. Maybe we should turn it around if you're thinking about ethical implications and kind of like say, well, we found out that our models are biased and we're actually able to quantify this and we can publish this and can tell you, well, there is this kind of bias in this data and kind of like make people aware of these issues. Because what we do engineering models and we do classifications, and at the first point we have a lot of false positives and it's the fault of the model. And then afterwards we find false positives and we can go to the engineers and we can tell them, well, there is a false positive, but maybe your data is wrong and we can improve quality there. Mm-hmm. So maybe that's an approach we could take in the future.
Yeah, I think I totally agree. And that's kind of a more optimistic way of posing the problem, and maybe that's more constructive. And this talk that I mentioned from Mikhail just a couple of talks ago, I don't know if you've seen it, but he presented a Python package that is called ELI 5, explaining it like I'm 5. It takes a model and then tells you, how the model makes decisions. So it doesn't necessarily answer the question whether it's biased or not, but it might help you interpret it and then be able to answer it. So I think there's much more work to be done in this area, but going this direction, I think, is the right thing to do.
So what are your concrete recommendations with respect to, I mean, you just said be aware of this stuff. Like to pick some of the most problematic examples, predictive policing, using that to figure out where to deploy police, predicted rate of recidivism, and something that started to happen recently, at least in the US, is using that in sentencing judgments. Mm-hmm. So making people's prison sentences longer if you think they're more likely, if the model says they're more likely to be recidivist. Is this something that absolutely shouldn't happen, or just, what is your specific recommendation? Be aware of bias?
I mean, as soon as you get into...
I mean, if I could just point out, you cited the criminal justice system of the state of Florida is like an anti-pattern for how to do stuff.
Right.
It's one of the worst examples in the world of how to do these things. And so any model working in that system is going to give you garbage results.
Okay. Sure, it's still something that I believe should be pointed out. So, I mean, as soon as you get into ethical questions and moral questions, there are no silver bullets. So I can't give you a recommendation saying do that, because even if I tell you do that and it's right most of the time, there will be cases where it's wrong. So, I will hesitate to give you a straightforward recommendation. That's why the best thing I can come up with is think about it. If people building Compass explicitly thought about racism and tested for it, this could be avoided. Now, of course, Compass is embedded in a larger context of the whole justice system of the state and also the US. So, it wouldn't prevent everything, but we have the power to change things a little bit at the time. And I think we should try to do that.
Okay. There was an idea that we can find out that some model is biased and try to fix a bias by some fixes. But I don't really like that, because if you fix it by hand, you can interfere your personal bias into this data set. So, and the second point is you are getting a fake reality instead of something.
Sure. So it's a good point, but the way I look, and I kind of also thought that for a while, but the way I look at it, and I'm not sure if it's right, but it sounds more right to me, is that it's not about taking pristine data and messing with it. It's taking messed up data and messing with it in a different way. There is neither of them is absolutely right, but you're messing with it manually because you have the context, you understand what it represents, and you have opinions about, okay, I think this shouldn't happen, so I'll try to make sure it doesn't happen. Now, there are very few examples where you can just take data and say it's the perfect reflection of the world. So to me, that's kind of the answer. You just try to make things a little bit better, but none of them is like a true state. The data you have after you gather it is not true in an absolute sense.
Thank you for your talk. I think it's very important, and maybe it's more kind of a remark, but I have a question attached to it. So I think, isn't the problem maybe the same if we had in statistics all the time? It's that we use correlation because we are just unable to get causation really, and therefore actually all these methods, I mean, as an ethical rule, should be only applied to things which have not really hard negative consequences for an individual, because every classifier will, for individuals, get wrong answers. So independently of how we do this, I mean.
Okay, so I mean, I'm not quite sure what the question is, but sure, there are. I think thinking about it from like a correlation perspective, it's true sometimes, but there are other things that are much more difficult to put in that context, like reinforcement learning. You know, there are. Once you start getting into that, you know, intelligent agents, they might also, like the relationships between things that they do and the reward they get might be very non-straightforward. The reward they get might be maximized in a way that is totally not what we actually intend them to do. And it's just, I think that's part of the problem. But there are many different areas that can be kind of, many different problems that can be discovered when you think about what you do from that perspective.
So I like the idea somebody mentioned over there of, okay, so you've taken this model and run it against this corpus and found out afterwards, oh wait, there's a lot of bias here because of the corpus, turning that back around and saying, okay, so what do we need to do to change things so that in the world, say the news stories are
Sure.
less showing bias or things like that, so that we can actually turn it back and fix the world.
Yep. Yeah, absolutely. So I think, again, no easy answers, but the reason why I think this is important is that when you build a solution that's biased in a way, it doesn't only reflect the world, it actually reinforces the bias because of this, you know, perceived objectiveness. People tend to trust things like that. So you actually are making things worse if you do that by not, you know, by not releasing biased models or whatever you can do. That's one way to prevent, you know, injustices in the world, as grandiose as that sounds. But obviously, we should, you know, go out of our bubble. And there are also lots of other things we could do. You know, get involved in your, I don't know, local newspapers, you know, help them out, or I don't know, join a political party, or whatever you think is the right thing to do. You know, doesn't necessarily have to do with programming.
We have time for 3 more questions.
Hello. One of the things that seems to happen is that people publish a story saying, publish an article saying this news outlet or the news outlet news on Google News is biased in this way, but would you suggest that companies try to take these these machine learning algorithms and run them internally, and then analyze purely their own data to see if they can detect bias in-house, so they don't need to be, well, named and shamed. They can do it internally to maintain their standards and then try to annihilate the bias initially.
Yeah, so I mean, I think of that a little bit like you know, any kind of QA, like finding bugs. You can try to find them in-house, or you can wait for your customers to tell you. It's the same thing here. You can have some process for trying to discover these things before you release it, or you can wait for ProPublica to come to you and say, hey, you know, you're biased. So absolutely, I think it's not, I don't think it's very common right now, at least I'm not aware of that, but I think this kind of testing of models, whenever you retrain your model, you have to test whether it's still performing well or not. We should definitely think of incorporating these kind of checks into these processes too.
You mentioned there was a study done on Instagram and Twitter users to determine future likelihood of depression. Firstly, how did they possibly find out if people were depressed in the future unless it was a controlled study? And number 2, what are your thoughts on if you're doing a medical study on people, you have to run it by an ethics officer or an ethics board to make sure that it's ethical. Do you think something like that should be mandatory for models which will affect people's lives in this way?
Okay, so to answer the first question, I'm not really sure. I will have to reread the paper, or there are references here if you want to do that. It's a good question. The second question was, do we need ethics committee to like approve our models when we use them in production, basically?
Just your thoughts on whether the industry should move towards what the medical industry is already.
So should the software industry move to the model that medical industry is doing and have an extensive ethical review? I don't know. There are definitely different requirements. I think some software is sort of mission critical and like governs medical equipment, for example, and it definitely does go through this process already. If you're Instagram, it might seem like, oh, we're just posting filtered photos, what can go wrong? So you might think that's not necessary. But then again, things like this happen and all of a sudden you're involved. So I don't know whether some kind of mandatory official requirement for doing these things would be a good idea, because it has a set of drawbacks as well. You have to iterate much slower and so on. But I think where we are now is at the other end of the spectrum. We don't think about it enough. I think we should pull towards that side, even if we don't want to get all the way there.
I have a last question. What can we actually do to make the general public more aware that computers actually could be as wholes?
Great question. If you're a writer, write stories. If you're a filmmaker, make animations. I think if we are aware of that as a community, and it seems like we are getting aware of that, things will seep through. Like there's lots of sort of knowledge or myths, if you want, about AI in the general public already. Everyone knows Siri or like Google Photos and stuff like this. These things slowly seep through, and like my most boring but straightforward answer is just be aware of that and everything else will follow. But if you want to specifically focus on public outreach, I think that's awesome, but I'm not an expert in that area, so.
So the question about how did they find out whether the person was depressed was people who reported being diagnosed as depressed. They did a study on a lot of people and used that to predict. So they had posted on Twitter, for example, that, hey, I just got diagnosed as being depressed. So that was where they got the data on, oh, they're depressed.
Thank you.
Thank you. And let's thank Maciej Gryka again for his talk.
Thank you. Don't forget your sweets.